Yeah, I was saying today's lecture is going to be enjoyable and easy. As we transition to 1 to 100, you will see this very often. In fact, you might have seen this in the CI/CD class as well. Okay, this is CI/CD, like it's so simple. And ऐसा ही होता है. Most, as you move to system design, as you move to senior roles, the things that you are learning are harder conventionally. It feels very jarring. But once you understand them, they are so easy. And they give you so much power कि अच्छा this was it, and you can negotiate better salaries or answer questions in senior engineer interviews, so on and so forth. And they're also more interesting. They are one step ahead of everything we've done. Today is one such class. Before we start the class, I will share some where we are at, what we are doing, what we are going to do. I've written a few points. This is purely based on talking to a few people who are now being referred. And I'm seeing some inconsistencies, some things that you should try to fix if you are going to, if your goal with the cohort was getting a job. Then number one, if you weren't able to afford much, you got 0 to 1. 0 to 1 people can stay till the end of the month, learn some SE stuff for the next 1 month. And 0 to 1 is almost complete. There are some very off-topic random things like OpenAPI spec that we need to cover, certbot. I'll add them as offline videos, but I think it's time to move on to some solid senior engineer stuff. Start contributing to these repositories. You have enough knowledge. A lot of your peers are already doing it. And there are decent bunch of issues. There is like a lot of things to improve. One small thing I can point out is, since Soham has lectures now, or, we'll probably have DSA lectures. A very good thing to add might be if this is a DSA track and, there is a problem, the problem statement comes right here. It's not very difficult to add. There are some parts that are difficult, but UI is easy, simple, backend is easy. There are harder stuff, which, we'll cover in 1 to 100, but simple things you can start to pick up. There are a lot of issues there. I would start contributing. Only then do you know, do you really understand it? Can you understand other people's code? So people who are in 0 to 1, try this out. There are a lot of people contributing. I'm not being able to keep up with PRs, but I will. I'll be spending a decent chunk of time here. Please focus on English for remote jobs. Unfortunately, the first filtering criteria is everyone wants to know, can they talk? Do they have decent communication skills? This was a great thing about Abhishek. This is a great thing about Harpreet as well. Sorry, I think it's Harpreet, right? Yeah. They're both pretty good in English. Even though they're good at Hindi, they're good in English as well. Speak slowly, get a mic, have a decent background, simple stuff if you're going for an interview. As an intern, I think this is decent, is to ask, Harkirat, you to talk about 4CR. Yeah, as an intern, even I did not make this much in college. Like this little bit more than this was my Goldman offer. So I think as a college intern, this is a decent task. As a fresher full-time, this is a decent task. If you have more experience, frankly, pick and choose, but I think this is a decent task. That's all I wanted to share before we start. We're very close to I'm officially concluding 0 to 1, but there will still be more classes that will be beginner friendly sort of, and a bunch of offline videos that will come throughout this month. 0 to 1 people can stay this month. With all of that context, let's get right into today's session. Today's session is on Advanced Backend Communication. This is the first topic of 1 to 100, where we'll understand. We were able to understand HTTP until now. What else exists? How can backend systems talk to other backend systems? That is the context of today's class. The most important implementation we will do today will be of Websockets, which is this thing you see right here. But there are many ways for backends to talk to other backends. We'll discuss a bunch of these ways today. We'll discuss the implementation of WebSocket today. Tomorrow probably we'll go through either PubSub or messaging queues. That's the goal for this week. Okay, very jarring but actually fairly simple backend we're able to cover. Let's get right into today's session. This is a brief graph of how backends communicate. But before that, you might ask, Harkirat, backends communicating? Why does one Node.js backend need to talk to another Next.js backend or Golang backend? Why does this need to hit this server? Usually communication happens between a client. There is a browser over here that hits a backend system. Why is one backend system talking to another backend system? And the answer is, as your application grows, you don't want to keep everything in a single server that is exposed over the internet. You are literally saying, this backend server, people can hit from their browsers, and I will put everything here, including sensitive things that, you probably don't want exposed here. Also, there is something called asynchronous processes. Harkirat, asynchronous, I understand a little bit. What is an asynchronous process? A very good example is a notification that you might get on your phone when you transfer via Google Pay. When you transfer someone 100 rupees via Google Pay, the actual transfer minus 100 on your bank plus 100 on their bank needs to happen on this layer most probably. Most probably, the primary backend needs to take care of it. But the notification, the email eventually going out to them, the push notification coming out, the SMS going out can happen in its own time. Even if it happens after 10 seconds, it's fine. The primary backend server that's handling the core of your business should probably not be worried about this. Another good example is analytics. If you have a lot of people coming to your website, your primary backend server, your Express server shouldn't be tracking, oh, 1,000,000 requests are coming, let me put them in the database. It should be offloading all of this to someone else, even if the final response, comes after some time. Another good example of this is if you go to any exchange or backpack.exchange, for example, the trading bit, if I actually trade something, needs to happen instantly. But if you look at the rewards, which, let's say show you how much volume have you done, which, as it says here, $16,000 or whatever. This, even if it happens after one day, it is fine. This is not a necessary thing for the person to see right now. But trading needs to happen instantly. These are examples of core system backend handling the, requests of the user and core thing that they need instantly. And then a bunch of backend processes handling asynchronous requests. Okay, chalo, after a day, we will calculate how much money have they made. Another good example of this is if you go to Dukaan, if you've heard of Dukaan, Shopify, if you go to mydukaan.com and sell some t-shirt, you will see all of your orders. Where is Dukaan? I mean, I won't open the dashboard, but you get the idea. If I log in over here, I will see a dashboard like this. The total sales are usually, they come at end of day. At end of day, you see, acha, today you made 54,000 rupees sale. But every order you're seeing immediately. So this is an asynchronous process that will calculate how much money you made throughout the day. Everything else is a synchronous process. These asynchronous processes usually run on different servers, and your primary server needs to talk to them. It needs to tell them, okay, bhai, please after one day, calculate the total money this person has made today on Dukaan. What is Dukaan? It's a place, it's like Shopify, an e-commerce website where you can sell products to other people. And then you have a dashboard where you can track how much money they have, how much sales they have done, and their total sales of the day, so on and so forth. So this is how general backends are architected. You don't put everything in a single place. That's the worst idea ever. This is also called microservices. If you've heard of it, you have various small services talking to each other. You don't have one monolith. You don't have one very big server. That is why backends need to talk to each other. The question is, how do backends talk? Does this backend server send an HTTP request to other backend server? Let's take an example. Let's say you're on Dukaan and someone made a sale, as in some end user bought your product. A request will come here, okay, the product has been bought. You will update the database, okay, the product has been bought. Should you tell the aggregator service? What is the aggregator service? The service that is aggregating your sales for the day via an HTTP call. Okay, bhai, please add 200 rupees to their total sales of today. Or should you send it to a queue where you can, put a bunch of items in the queue? Okay, Harkirat sold one t-shirt for 200 rupees. Harkirat sold another t-shirt for 500 rupees, so on and so forth. And then another process picks it up in its own time. Okay, acha, 200 rupees I will pick, I will add to the database. 400 rupees I will pick, I will add to the database. Or should they communicate via something called Websockets? We'll discuss what these are today. Or should they talk to each other via pub subsystems? Harkirat, what are pub subsystems? We'll discuss tomorrow most probably. But as the name suggests, they're called publisher subscriber systems. Your backend one can publish an event and that says someone has bought a t-shirt, and then this backend can pick up and send them an email. This backend can pick up, send them a text message. This backend can pick up and aggregate their sales, this number in the database. So there are, various ways for backends to talk to each other. We'll discuss one of them today. I hope it's clear. Okay, why do backends need to talk to each other? Cool. Given that context, let me share some examples of, when backend systems would talk to each other and when you would have such decoupled backend systems. Good example is for Paytm. When you say I want to transfer 100 rupees to someone, it will immediately talk to the database, immediately do a plus 100 minus 100. It might actually do this also via an asynchronous process, but chalo, let's assume this happens instantly. But it will push onto a queue, send them a notification, send them a SMS on their phone number, send them an email. Harkirat, why can't it do it over here? What if the email service is down? What if whoever you are using for phone number is down? Will you, make the plus 100 minus 100 in the database and keep waiting? Okay, bhai, phone number, okay, it hasn't happened yet, retry. Do you want your end user to wait? No, their thing is done. They wanted to swap balance. The balance has been swapped. Everything else can happen in its own time, which is why you push these onto queues. Harkirat, what are queues? Well, as the name suggests, it's a queue. But like, Harkirat, show me a real implementation of a queue. We will see this tomorrow, most probably. But like a good example here is, RabbitMQ, if you've heard of it, or Redis also has a concept of queues. I will push this onto a queue, and then the push notification service, if it is down, it's fine. It will still remain in the queue. Whenever it comes back up, it will start to pick up messages and send people push notifications. Harkirat, then the push notification might take a lot of time. It does. When you send someone money on Google Pay, when your Swiggy order is delivered, you don't instantly see a notification. You see it after 20 seconds, sometimes after 100 seconds. So these systems can be highly asynchronous. Another good example is lead code, which is something like we're trying to build on projects.100xdevs.com. People come here and are able to, submit coding problems. When someone comes to your platform and submits a coding problem, should you on this backend itself evaluate that? You shouldn't. Why, Harkirat? Because the C++ program that they are submitting might have an infinite for loop that will take up your core of this main backend system for running that while loop infinitely. So you definitely don't want to run other people's code directly over here. Harkirat, where should we run it then? You should run it on, some separate service, some separate server. You should not run it on the primary backend. So what can you do? You can take the user's submission and push it onto a queue. Most probably lead code and even us, when we build this, we'll have two queues. A premium user queue, where whoever has paid, their submissions will reach here. And then a free user queue. Someone has not paid, their submission will reach here. This is being handled by a small machine or, just a single machine or two machines. Premium user queues is being handled by a bunch of big machines. There shouldn't be any record here for more than 3 seconds because these people have paid. They need to have a good experience. So this is another use case where, your backend would delegate a task to other backends. And then eventually, whenever the submission is complete, this big machine can tell the database, accepted, rejected, TLE. And then, the end user can just poll the backend and get their status. That's exactly how LeetCode does it. We'll see this very soon. But that's a brief of backend systems talking to each other, how you build bigger backends as you have complex applications. Harkirat, what is a complex application? Great example of a complex application is LeetCode, where this is the complex part. In Swiggy, delivery tracking is a concept part. The driver keeps moving again and again. That system needs to, track them and notify the user that they are close enough. In case of Paytm, as I said, notifications it's not the difficult part, but it's the part that needs to be delegated. In case of an exchange, as I said, the order filling needs to happen immediately. When you go here and buy, or if you go here and sell, then the buy or sell needs to happen immediately. But reward point calculation or, notifying the user your order was filled can happen in its own time. Another good example is if I withdraw my crypto. If I say I want to withdraw, whatever, I have 36 USDC. I want to withdraw 30 USDC. Click on continue. This will also happen in its own time because this is dependent on the blockchain. Whenever something is dependent on another service, for example, you never buy phone numbers to SMS other people. You usually depend on another service. Twilio is a good example for this. If you've heard of Twilio, Twilio lets you send SMSs to other people. Similarly, SendGrid is an example of a company that lets you send emails. These are highly unreliable APIs. Phone numbers can go up and down, SMS might not be received. Whenever you're dependent on something like this, you maintain a queue. Why, Harkirat? Because whenever this service pulls the message, if it fails, it can just push it back to the queue and then retry after some time. That is why a queue makes a lot of sense for systems where you're dependent on an external service. What is a good example? Blockchain is a good example if you're ever doing withdrawals on an exchange. Or, this is also a good example. Sending SMS, sending emails, so on and so forth. That is a decent context. I'm hoping this is straightforward. Let's do a quick poll, but then let's proceed to the next section. Are we good to go, guys? Yes or no? All right. So next up, let's understand the types of communication. This is common interview question. Whenever you're in a SE interview, they will ask you, in your last company, was there backend communications? How many did you have microservices or did you have monoliths? You will say, sir, we had microservices. That's the more, authentic answer to give. Then they will ask you, how did your systems communicate? Synchronously or asynchronously? Now this is jargon. I did not know what I knew what HTTP means. I knew what WebSocket means. I knew messaging queues, pub subs, everything I knew when this was asked to me in an interview. I did not know what is synchronous communication, what is asynchronous communication. But if you think about it, it's pretty obvious. If one system is talking to another system directly, as in either via HTTP, ignore this, you don't know WebSockets right now, so feel free to ignore this. This is also debatable if it's synchronous or asynchronous, but HTTP is a good example of, okay, bhai, one system is directly pinging the other system. This is one system, this is another system. It's directly telling the other system, okay, bro, please send message via, let's say, an HTTP call. This is a synchronous call. Okay, bhai, abhi ke abhi karke bata. Do it right now and give me a response. I will wait for your response. When you are waiting for a response from another service, what is that? That is synchronous. What is asynchronous by the same, argument? When you don't wait, when you just push it to a queue and you're like, someone else will handle. As long as it was pushed to the queue, you are good. You don't have to wait for acknowledgement from the other service. Ki haan, I picked it up. You push it to a queue, you move on, you do your own thing. What is a good example? Messaging queues. When this backend is putting something in a messaging queue, it is putting it there. And it's like, okay, someone else will pick this up and send the final email. My job is done. That is what asynchronous communication is. Messaging queues is a good example. Pub subsystems are a good example. Server-side events, debatable, but haan, theek hai, chalo, I did put it here. And WebSockets, as I said, is debatable. Why is WebSockets debatable, Harkirat? If you know WebSockets, I'll share quickly why it's debatable. Because when you have a WebSocket connection, you send the other side data, you don't wait back for acknowledgement. That doesn't happen in HTTP. When you send some HTTP data, you wait for a response. When you send a WebSocket data over a WebSocket wire, you don't really wait back for response, which is why it's very debatable whether it's synchronous or asynchronous. I would say it's synchronous because you are immediately sending the other service, okay, bhai, do this. Versus in these asynchronous systems, you are publishing to something, a messaging queue, a pub sub, and then the other services can pick them in their own time. You're not telling the other service directly, okay, bhai, please do this. So that's a brief about an interview question. How did your backend systems talk in your last company whenever you're giving an interview? Sir, they talked asynchronously. We had messaging queues between our main primary server and our email server. The primary server would push things onto a messaging queue. The email server would pull it from it and, send it out to the end users. It's a brief of the types of communication. This is just sort of an interview question I had, so I thought I'll share. WebSockets is the next one. Harkirat, why are we learning WebSockets? Is this also used for backend systems to talk to each other? Not really. WebSockets is rarely used for backend systems to talk to each other. It is usually used for a browser to talk to a server. Harkirat, browsers to talk to a server via HTTP. We have done this so many times. You create an Express server. Why are you introducing a new protocol called WebSockets for browsers to talk to a server? Good question. The answer is WebSockets provide you something extra. There is actually a small inefficiency in HTTP, not inefficiency. It's just something that's missing that WebSockets provide you. Okay, Harkirat, what is that inefficiency? Before that, let's understand what are WebSockets. The official definition. WebSockets provide a way to establish a persistent, full duplex communication channel over a single TCP connection between a client, typically a web browser, can be a backend system as well, but typically a web browser, and the server. Something like this. It creates a persistent connection. Harkirat, how is it different from HTTP? In HTTP, you don't create a persistent connection. If this is your browser and this is your server, you send a request to the server, you wait for the response. As soon as you get the response, you close the connection. It is not persistent. Send, get back response, good to go. What are WebSockets? WebSockets say, a lot of communication needs to happen between the client and the server. Let's create one single connection. The client or the browser can send events to the server. The server can send events to the browser. Hence the word full duplex communication. What does full duplex communication mean? It means duplex, both the sides. Browser can send events to the server. Server can also send events to the client. Can you ever do that in HTTP? You can never do that in HTTP. HTTP means server can't send events to a browser. You cannot go to the server and be like, fetch http://user_domain.com/something. The server can't ever find the browser. The browser can find the server by hitting a certain endpoint, and the server can respond back. The server can never push events on its own. WebSocket server can do that. That is why you might want to use a WebSocket server for use cases like these. I've given this sort of definition. What is a use case, a practical use case of WebSockets? When do you want server to push events to the client without the client even asking for it? If the client needs something, it can just ask for it again and again, right? Why does the server need to push? Usually a good example here is again exchanges or 10 different applications, but Exchange is a good example because you'll see a lot of activity here. Can you see these numbers going up and down? Can you see these trades? So many trades are happening. People are buying, people are selling. If you use HTTP to get, what sale has happened, can you give me the next order? What is happening here? Some event is happening. Every time you see an order here, someone is going and, buying some Solana. Someone clicked on buy over here. You see that order over here. All of these coming back. If you do this via HTTP, you will send 1,000 requests to the server and then every second, and then it'll respond back. Every time you send a request, you do what's called a handshake. I don't know how many of you have gone through computer network classes, but whenever you're sending an HTTP request, whenever you're doing a fetch, for example, to api.backpack.exchange/get order, something like that. Whenever you're sending this fetch request, you are sort of doing a very big overhead of sending some headers and then getting back an acknowledgement and then again sending back another acknowledgement, a three-way handshake, and then you actually send the data. So there is a lot of overhead you have to send with every request. If you have to send 1,000 requests a second, then you have to send this 1,000 times. Not good. Which is why you want to use WebSocket servers. The handshake happens only once. Handshake happens once, and then everything after that is you send data, you send data, you send data, you send data. And in this case, the data is, the orders that have been placed. Harkirat, can we see this in action? Yes. If you right click on inspect and click on the network tab over here and refresh, you will see a WebSocket connection, which is very hard for me to find because my search bar went away. This happens every time, but let me search for it. There you go. ws.backpack.exchange. If I click on this, very similar to an HTTP request, I see a WebSocket connection. And if I click on messages, I see a bunch of messages the server is sending me. If you look at the body of these messages, you will see it is sending you back, okay, the depth change over here, the depth change over here. Okay, what is depth? Don't worry about it. But any real-time events that you're seeing, all the trades that are happening, this order book being updated is coming via a WebSocket connection. This is a primary use case of where you want to use a WebSocket connection. Why, Harkirat? Why can I not keep sending, okay, give me the current order book, give me the current order book overhead? You'll be sending 20, 30 requests a second. Just create a single connection. Tell the server, okay, bhai, please keep sending me messages. And then the server will just keep sending you the current state of the order book, the current recent trades that are happening, so on and so forth. That is what WebSocket sort of connections let you do. Use cases for WebSockets, real-time applications. What is a real-time application? A chat application is a good example. Even, this, everything you see over here is a good example. All these events are happening in real time. You don't want to refresh the page. You want these come to you quickly. That is why. That is one place where you want to use WebSockets. Live feeds. This actually is a better place to put, a crypto exchange. Financial tickers. The graph going up and down. Even if you open Binance, you will see, a very similar order book over here that is getting updated. This price graph will go up and down. This price will keep changing as orders get matched. As you can see, it became something else, then something else. This is a real-time application. A ticker being, the current price, is a good example of where you want to use real-time communication. Interactive services, Google Docs or, whatever, Replit with two people typing at the same place is also a place where you want to use WebSockets. Why not use HTTP? As I said, you will keep sending requests again and again and again. And you don't want that. You don't want to send. There's a lot of overhead that comes with every request. What is overhead, Harkirat? You're sending a lot of extra data along with, okay, please give me sole price. You are doing a three-way network handshake, which is, very computer networks concept. But if you've read through it, you're sending a request. The server is responding back, I got you. And then you respond back with, I also got your acknowledgement. You do a three-way handshake and you are doing it again and again for every HTTP request. And you can still do this. Companies still do this. This is, even though it's an ugly approach, companies still do this. In fact, LeetCode does this. When you go to leetcode.com and try to, create a submission, let me quickly do that. Oh my God, my eyes. White mode. Okay, there you go. Dark mode. If I do a submission over here, if I go to some problem, open the network tab, click on network. When you click on submit, as I said, the application might take 1 second, 10 seconds, doesn't matter. Eventually it will do your submission and it needs to push an event. It needs to tell you, okay, your submission succeeded or failed. So WebSockets is a good use case here because the server needs to push an event. Whenever you're submitting to LeetCode, if this is LeetCode server, you tell them I have created a problem or, submission. It will tell some random, it will push this onto a queue. Some other service will pick this from a queue and then actually do the submission. And then whenever the submission is succeeded, it will put this in the database. Okay, haan bhai, successful or failure. Ideally, when this event happens, it should also tell a WebSocket server, okay, the submission failed or succeeded. And then this backend WebSocket server should respond back to you. Okay, you got a wrong answer. That's how I would expect to build this system. But how does LeetCode do it? LeetCode uses something called polling. What they do is, okay, bhai, you submit the problem. It is still doing a very asynchronous operation. Request going to a queue, getting picked from a queue, getting solved, and then the final submission being stored in the database. But the user doesn't connect to the LeetCode server via a WebSocket connection. I repeat, the user doesn't connect to the LeetCode server via WebSocket connection. It just keeps asking every 1 second, is my submission done? Did I get a TLE? Did I get a wrong answer? It keeps sending that request again and again. It keeps polling the LeetCode server. Did it happen? Did it happen? This is another way to do real-time communication. You can always poll a server. Okay, bhai, did my thing happen? You wanted to send me something. Can you please send me? Rather than the server sending you something, you can just keep asking again and again. Do you have my data? Do you have my data? Do you have my data? And that is how LeetCode does it. If you click on run over here, you will see a bunch of /check requests are going out. The first request does the submission. This one, most probably interpret solution. We look at the payload. I am sending my code over here, and then a request goes out to /check that responds with status pending. Another request goes out to /check status pending. Another request goes out. I am polling. Do you have my submission? Do you have my submission? And then eventually, when this whole process succeeds and the database has your final solution, when you ask for the data, you get back, okay, your submission was accepted, rejected, whatever, run code error. So yeah, long polling is another way to do real-time stuff. Should you do it? Probably not. Depends. In this case, works. Does it work in case of, a place where so much data is incoming so fast? No. For an exchange, does not matter, does not work. For a lead code like solution, might just work. In fact, it does work. They're such a big company, they still do this. Cool. That's what are WebSockets. Next up is just a bunch of implementation. How do you create a WebSocket server? How do you scale a WebSocket server? So writing a bunch of code, fairly straightforward code. Let me do a quick poll. Are we good to go, guys? All right. So WebSockets in Node.js. Let's understand how can you create a server, a WebSocket server. How can you send data from a server to a client to a server? There are many implementations of WebSocket in Node.js. Just like you can create, if you want to create an HTTP server in Node.js, you can use Express, or if you remember, you can use, I don't know if I introduced Koa, but that's another HTTP framework, or you can use Hono. These are all implementations of the HTTP protocol. These are all implementations of the HTTP protocol. These are code that a bunch of people have written, and then you just use their code and create your HTTP server. You don't worry about how the HTTP protocol actually works. These developers have worried about that. You just use their code. Similarly, WebSockets is also a standard. You can read about how should a WebSocket server be on, IETF, this RFC. And, it'll tell you the WebSocket protocol does this. And then, you can read about how a WebSocket server should be built. When you're in a trading company, if you ever join Jane Street, if you know what's his name called? The YouTuber called Joma Tech. He used to work at, some trading company. He built, his task was go to this, read about the protocol and implement it from scratch in C. A lot of times, companies that really care about latency of systems talking to each other will build a WebSocket server from scratch in, some low-level language. But does it matter for us? No. We will highly depend on, someone else who has written all of this code in JavaScript, C++, doesn't matter. Just because you're using a library like this that says, that's on NPM, doesn't mean it's written in JavaScript. It actually can be written in C++ as well and have an API on top that's in JavaScript. So I don't know how this WebSocket client is written, but it could have just been written in C or C++. Either way, these are three popular implementations. The first two are pure WebSocket implementations. The third one, called socket.io, is something you might have heard of, might have seen. This is the first beginner-friendly way to, do full duplex communication for backends to talk to frontends and frontends to talk to backends in a persistent way. You probably don't want to use socket.io. There are a few problems with it. The biggest one being even though it's written on top of WebSockets and you can sort of convert a socket.io server into a WebSocket server, it's harder to support multiple platforms. If you create a socket.io server, your website will be able to talk to it. But if you're creating an exchange, you also have to create an app. What if you create an app that's in Android? Then you need a socket.io implementation in Android. There is one that exists. But what if you want to create, a Rust server that needs to talk to your socket.io server? Then you need socket.io implementation in Rust. And all of these exist. Like there is a socket.io Android client. There is a socket.io Rust client. But these are not maintained as much. WebSockets is a very global protocol. So WebSocket clients generally exist very frequently. There is an Android WebSocket connection. Websites to support WebSockets by default. So in the browser fetch, just like there is a browser fetch API, if I right click Click on inspect. Just how fetch just exists as an API to send a backend request, WebSocket also exists as a construct on the client that you can just use. So browsers to support them from scratch. Rust also has a WebSocket client implementation. So even though you can use Socket.io, probably shouldn't. A lot of companies started here because it's very easy to use it. It gives you some constructs like rooms that let you do, very simple, that let you send data to clients very easily, but you should avoid it and just stick with the core WebSocket protocol. Now let's get to some coding. Fairly straightforward code. If you've written an Express server, this should be very easy to write. Let's write WebSockets in Node.js, but the protocol remains very similar. You can write a Node.js server, a WebSocket server in Rust, in Golang, doesn't matter. Everywhere it's, the protocol core remains the same. Okay, there is a persistent connection between a client and a server. If you want to, feel free to follow along. I'm going to write this code, even though it's fairly straightforward code. But yeah, let's write it from scratch. The first thing you have to do is create an empty folder in your laptop. So let me do that. Let's call it week 19 WebSockets. And then let's initialize an empty Node.js repository here. npm init -y to create an empty package.json. I repeat, create the folder, go into the folder, and then do a npm init -y to initialize a package.json. Then initialize a tsconfig.json by running npx tsc --init. Now open it in Visual Studio Code. All the steps are here. I'm assuming it's pretty straightforward by now, so not going to wait a lot, but I'll still do a poll. Week -19. All right. I have the project open here in Visual Studio Code. If you look at the files, simple package.json, simple tsconfig.json, create a new folder, call it source, create a new file, call it index.ts. I will take a pause here and do a poll. Feel free to take your time if you are lagging behind. I know a lot of people like to code as well. Can I proceed, guys? Can I proceed, yes or no? And select no if you want to wait for 5 minutes. Can I proceed? No. Okay, that is fine. I will wait. No rush. Let's take a small mini 5-minute break. Let me answer a few questions in Q&A until then. All the steps are here. Try to create a WebSocket server by your own. Can't we use HTTP pipelining for making HTTP persistent? First time I'm hearing this, HTTP pipelining. And the small answer is probably no. Multiple HTTP requests to send. Oh, okay, I have heard of this. It lets you send multiple HTTP requests with a video conference. Does it let the server respond back without you sending a client request? Maybe it does. There are a lot of sort of ways for a front end to talk to a backend and exchange data. Two more protocols that happy to talk about here are Quick QUIC and WebRTC. If you use both of them, then also a client can talk to another client or another server persistently. There are various ways for you to do two-way communication between two clients. But yeah, WebSocket is the most popular one for real-time communication. Won't the server get overloaded with so many multiple connections? It will. So more horizontal scaling in case of WebSocket architectures. That is correct. We will get to that in the last slide. Is that why lead code is ditching for cost savings? I think it's just complex to maintain a WebSocket. Why do you want to create a fresh server and then make your user do two connections, one an HTTP connection every time and then another lead code server? I think just to keep things easy, they're doing long pull. I don't think money saving is something in their head. Redis is not open source. Going to ignore the. Will you cover Rust as well in Web3 cohort? Something I'm thinking. It will be very long if I do, but we won't be able to do Solana contracts very well if we don't know Rust. We'll see. What is polling? Long versus short polling. Polling is what lead code is doing. Every second, bro, do you have something? No, I don't. Bro, do you have something? I don't. I have something? I don't. Long polling is, okay, bro, whenever you have something, respond back. Take your time. I know you have something. Your submission will eventually succeed. Whenever you get the response, maybe it's in 10 seconds, respond back to me. That is long polling. Okay, bhai, I'll wait. Keep my connection open. When you have the response, send it back to me. What is polling? Okay, bhai, do you have the response? Yes or no? No, I don't. Do you have the response? Yes or no? No, I don't. That is polling. What is long polling? Bro, whenever you have the response, send it back via this HTTP layer. Reshare screen. Okay, we'll just take a proper break only then. And 7 more minutes. We'll start at 7:50. Ishan Sharma, just ping Rookie. We need TAs for Web3 cohort. It'll be a lot of questions because not a lot of content on it. Please explain why not to use Socket.io. Yes. The reason I said was, okay, if you created a Socket.io server, very good. You created a website, very easily you can, connect from this website to Socket.io. But now you have an Android app. Now you have to include a new dependency in your code base called, io.socket.io, Socket.io client 2.0.0. Every platform, thankfully, so Socket.io has good support. It's not like it will not work in, a Java program or a Rust program. They have created clients, but it's not the core protocol that IETF created. IETF created WebSocket. Every language has a WebSocket support. Android, you can simply, you probably have to have a dependency here, but website, you simply have WebSocket as a construct. Even in Android, a lot of support for WebSocket clients. What is a client? Something that can connect to a WebSocket server. Socket.io, all clients are community made. Okay, bhai, acha Socket.io came, so we will have to create a client in Rust, in Go, so on and so forth. So in C. So for that reason, you will have a lot of dependencies. That's the only reason. Do it in Next.js. We will eventually, like today. Polling causes a lot of database calls. It does. You are polling it. Not a lot. Like you can handle this scale. How many people are coming to lead code at a certain point? 20,000. How much are they polling? Once every 2 seconds. Your database can handle 5,000 requests a second. What if adding to the queue and queue is down, does not accept it? Exactly. That is a beautiful question. The question is, okay, Harkirat. In fact, if you go to this video of mine, Harkirat Singh roadmap, full stack, somewhere I say if your queue is down, you're screwed. This one. Go through this video. Pretty much covers what we're covering today. Complete full stack roadmap. इसमें बीच में I abuse a little bit when I say if your queue is down, you're screwed. क्योंकि if this is your server and your end user is like, okay bro, I want to send my friend 200 rupees, and the queue where you are storing all the events is itself down, then what will you do? You can do a few things. Either you can revert the transaction. कि नहीं यार, sorry, you will not get 200 rupees. Our notification system is down. Probably shouldn't do it. If a notification gets missed, it's fine. What you can do is, send data to another backup storage for now. Whenever the queue is down, send the data to a backup storage. And then whenever the queue comes back up, seed the data from the backup storage. Harkirat, what if the backup is down? Yes. What if the server is down? Of course. If things are down, your people will see downtime. The question is, what do you consider as, an important event? If you consider push notifications as an important event, then even if the database call succeeds, you will revert the database call and tell the user, sorry, our systems are down right now. Please don't, we won't accept your request. What if backend 1 goes down? Then your website is down. If backend 1 goes down, then your end users cannot communicate to your system. On Paytm, if you send someone money, it will say request failed. It will show you an alert. Your primary backend is down, your primary backend is down. Doesn't happen very often. When it happens, your systems are down. You can't do anything. If your auxiliary services are down, then you're still fine. If your auxiliary services, this is down, it's still fine. Okay, main backend server is up, database calls are happening. If it is a Paytm application, the person's balances are being updated. They are not getting notified. It's fine. But the primary thing is happening. But if this itself is down, you can't send other people money. As simple as that. All right, I think we have 2 more minutes. Backpack WebSocket layer is simple Rust WebSockets, nothing new. Where do you implement queue, in the backend itself or on the server? It is, a queue is just a server that is running RabbitMQ. There is a server, like let's say whatever, an EC2 server that is running either RabbitMQ or running Redis, whatever is your queue implementation. It's just another machine. It's nothing special. It's a machine that is running a protocol or, a project that supports queues, that lets people push to a queue, that lets people pop from a queue. Having error while doing npx tsc -- init. Just copy a random ts config from a project here. Go to 100x devs cohort to open a random project, copy over the ts config from there. It just creates a ts config, so nothing new. Golang is not in Web3. We would have done Golang if we were doing Cosmos. We're not doing Cosmos most probably. So 1 more minute, guys, then we'll start. Since Cloudflare workers don't use Node.js as the runtime, then how do you use WebSockets there? I'm sure there's a WebSocket implementation there. Oh, are you asking about WebSocket clients? Are you talking about WebSocket servers? You cannot create Cloudflare workers, expose HTTP endpoints. They don't let you do serverless WebSockets. In fact, serverless WebSockets are very hard. So if this is the, your Cloudflare fleet, it only exposes things via an HTTP layer. If your question is, Kirat, can my Cloudflare worker create a persistent connection to another WebSocket server that's a normal WebSocket server? Probably can. Even though it's not in, I'm sure the Cloudflare runtime, supports WebSocket clients, but this is serverless. You probably never want a serverless server to have a WebSocket connection. What is the point of a persistent connection? This goes up and down very quickly. So yeah, serverless is a big no-no for WebSockets. All right, guys, 7:50. Let's proceed. We will be understanding a WebSocket implementation in Node.js, just writing some code. You can literally copy this code and ask ChatGPT, can you give me the same code in Rust? It will. Can you give me same code in Golang? It will. So, the code pretty much remains the same. The main goal is the idea. How do you create real-time connections? How do you scale real-time connections? Does not matter what stack your WebSocket connection is written in. Let's kick things off by writing it in Node.js. Hopefully by now, few of you have followed these steps. Let me quickly follow them as well. I'll do a poll after I finish as well. I created a tsconfig.json. I'm going to change the root dir to be ./src. I repeat, the root dir to be source so that all my source code is picked up from there. Out dir to be ./dist. Okay, the final output should be here. Then I will add the WS library as a dependency. As I said, there are various libraries, just like there is Express, there is Koa, there is Cow, whatever it's called, Hono. Similarly, there are various WebSocket implementations. We are using this one in the middle right here. So I will add that as a dependency. And then here is some code. We can rewrite it, we can copy it and go through it. It doesn't matter either way. This is like less than 8-10 lines of code. One thing that you should know about creating WebSocket connections. Whenever you're creating a WebSocket server, you are actually creating an HTTP server only. If you go through the protocol, the WebSocket protocol, how is it built? The first connection that the browser makes, the first request that the browser sends is actually an HTTP request only. It gets upgraded to a WebSocket connection on the server, but the first request that goes out is an HTTP request, which is why whenever you are creating a WebSocket server, there is actually an HTTP, server running under the hood. It is still exposed on a certain, port, which in this case is 8080. So you are actually creating an HTTP server. Only the server, whenever it gets a WebSocket request, it upgrades the request to be a WebSocket full duplex connection. So I have two implementations of a WebSocket server, one using the HTTP library which is a library we haven't ever used. This is the native HTTP library in Node.js. And then there is Express, which we have used many times. So feel free to choose which code you would like to write. In the end, there will be an HTTP server that will be handling your requests. So the very first thing I do here is create an HTTP server by calling http.createServer and saying anytime a request comes, just send them back hi there if it is an HTTP request. Very similar to me putting, a app.get/star, send the user some response. If you don't understand this, just go through the Express code. This is how you would write HTTP servers natively in Node.js. What does natively mean? It means without depending on any external library. Harkirat, you're saying we don't need Express. Yes, you don't really need Express. HTTP is good enough. Then why do we use Express, Harkirat? Express gives you very clean routing. It gives you an easy way to create middlewares. It has a very nice ecosystem of middlewares that you can use. That is why you use Express, but you can still create an HTTP server natively in Node.js. You never have to do what does natively mean? It means you don't have to do npm install HTTP. This comes bundled in Node.js itself. Create the server, and then we will use the WebSocket library, the WS library over here. Const WSS equal to new WebSocket server, and give it the HTTP server as an argument. You can also do this without HTTP servers. You can do no server : true. It will still create an HTTP server. Like you still need an HTTP server, but a lot of times you want multiple WebSocket connections. You want whenever a user connects to ws://api.binance.com/ws/one thing, they go to one WebSocket server, and then if they connect to whatever, I don't know, ws/user data, they connect to another WebSocket server. So you can read through, the code of WS library. They have a bunch of examples on their website. Let me quickly show you. They let you do very fine-grained configurations of, creating a WebSocket server. As you can see, it lets you do something related to performance. How much should you allow the user to send? Sending and receiving data example, sending binary data over the wire, so on and so forth. Like they have a bunch of examples. We are choosing a very simple example. The client can send some data, server can respond back with some data. So create an HTTP server, create a WebSocket server instance, new WebSocket server, and then this might seem a little jarring. So let's come to this later. But lastly, server.listen. You can remove all the WebSocket logic, comment all the WebSocket logic. This will just be a simple HTTP server that's handling requests. When you add the WebSocket logic is when it becomes a WebSocket server. This logic will remain the same irrespective of if you are using Express or HTTP. This logic changes. Okay, what HTTP server are you using, which right now is the native HTTP server. Now let's come to the most sort of jarring part of this specific library, because it uses callbacks. I hope you are comfortable in callbacks by now. If not, let's try to go through this code. It says WebSocket server .on connection, which means pretty reasonable, right? What it says. Anytime there is a connection, anytime someone, if this is a client over here, and then this is a server, anytime someone initiates a connection, control should reach over here. Control will reach this specific function, and you will get access to something called, you can call it whatever you want, but a WebSocket instance, a socket instance. And on this socket instance, you can be like, anytime there is a message, ws.on, not wss.on, ws, or to make it even cleaner, let's call this socket.on error. Anytime there's an error, just log the error. If this feels jarring, this is similar to the error, and then console.log error. And anytime there is a message, then to every client that is connected, there might be multiple clients, there might be this guy, There might be a second guy, so on and so forth. To every client that is currently connected on the WebSocket server, WSS dot clients dot for each, for every client, if the socket connection is open to them, because a lot of times it takes time for the socket connection to to open. A lot of time they might drop off. So this will, throw an error. So you should make sure that the connection is actually open and then send them the data. If the incoming data was binary, send them binary data. If the incoming data was ASCII or, simple UTF-8 or text, send them the text. This feels jarring, remove is binary as well. We will anyways not use any, binary data today. So this might feel a little weird. Here, too many things have happened. Also, this should be socket. These two are just registering a few events. This one is, if error happens, do this. If a message comes, do this. This is, okay, bhai, as soon as the user connects, send them a hello. Tell them, hello, you have connected to the server. Send them a message. So this is a simple send. These two are event registers. We have registered. Whenever there is an error on this socket, log the error. Whenever there is an incoming message, for every client that is currently connected, send them the same data that was sent by the end user. Very similar to a chat application, right? If you are in a chat application, if one user sends you a message, you broadcast it to everyone. You send them, this person said hi, you send them hi, send them hi, send them hi. In a multiplayer game, if I shoot you or if I move one step ahead, for example, if you're, this is like another company I used to work at that was a real-time game, very similar to a real-time game, something like this, where people can come talk to each other, move around. If I move, everyone in the room needs to know I have moved to, X, Y, which is why I send a message here. It gets broadcasted to everyone. Probably does not need to come back to me, but even if it does, it's fine. It needs to be broadcasted to everyone. That is exactly what our server is doing. Whenever there is a message, broadcast it to every client, because this is the most common use case. You might have some logic here. Okay, if client.room equal to Harkirat room, only then forward them the message or something like that. But let's say everyone is part of the same room in, a game like this. Everyone is part of the same room. If I move a bit, everyone's machine needs to see that Harkirat has moved to X, Y. And we can, ignore this part. I think that was a decent explanation, but if not, we will do a poll. Let's quickly run it and see it in action. Let's see, okay, whenever you create a connection, do I get back a message from the server? And whenever you send a message, does it broadcast the message to everyone that is currently connected? Let's see. How do you create a connection to this server? I have written some server code. I have written this thing over here. How can I write the client code? How can I make this client connect to this server? First, let's run the server. tsc-b to run the server. Compile the TypeScript code into JavaScript code. Node dist/index.js to run the server. This will start your HTTP server on port 8080 or whatever, WebSocket server, whatever you want to call it. Given that this server is running, how can I connect to it? You need clients, either a browser or something like Postman. Maybe Postman if it lets you send HTTP requests, maybe it lets you send WebSocket connections as well, or a mobile app. All of these can be various clients to an HTTP server. Let's use something called Postwoman, which was an open source project someone created a few years ago when I was in college. Eventually got acquired, renamed, I don't know. But it's called hopscotch.io today. So if you go to hopscotch.io, it looks very similar to Postman. It lets you send HTTP requests. It also has a real-time layer. I think someone told me Postman also supports this now. I could be wrong. But this too definitely supports this. I've used it many times. So what you can do is go to hopscotch.io. Let me just paste this in chat. And go to the real-time section. What is the real-time section? Okay, yahan se you can send HTTP requests. From here, you can create WebSocket connections. So let me try to create a WebSocket connection to localhost colon 8080. The way to do that is click on connect. Let me inspect, go to the network tab, and let's try to click on connect, see what happens. I'll wait for 15 seconds. What have I done? I've followed all the steps here to create an HTTP server. Then I have run the HTTP server locally by first compiling the code and then running the code. It is running on port 8080. If I go to localhost colon 8080, I do see hi there. So if I send an HTTP request, then this server does respond back with hi there. If I create a WebSocket connection, let's see what happens. Again, if I go to hopscotch.io and then this is my connection URL. Let me expand the network URL, click on connect. It says connected over here. And as you can see, there is a WebSocket connection in the network logs, very similar to the one I showed you on the Backpack Exchange or on Binance. Everywhere, whenever you create a WebSocket connection, you can track it in the developer tools. Thankfully, Chrome supports this now. And if you go to messages, you will see hello message from the server. Where does this come from? The server sent me a message. It comes from this line right here. What was this line? It said whenever a connection is created, send back to the user hello message from the server. If I put a log here, user connected, and then maybe maintain a user count, let user count equal to 0, connected, user count plus user count. I can see as users connect, and I can log that in my terminal. If I restart it and try to connect one more time, now I see user connected 1. Let me open another tab and connect from here. Now I see user connected 2. Let me send a message from here. Hello from client 2. Send. I get back some object. There's a bug somewhere. We can fix it very soon. But I do get back a message from the server. I also get back a message in my other. Where did it go? Oh, there it is. In my other one as well. It says object blob because I removed all the is binary logic. Let me add that back. Comma binary data is binary. Was this the logic? Let's look at the slides. Binary is binary. All right. Binary is binary, or you can just, I'm sure, default it to false and it will still work because we're not sending binary data, we're sending textual data. Let me restart. I've just reverted the code to what it was here. And then if I connect from here and then connect from here, it says 2 clients are connected because one is connected here in browser 1, another is connected here in browser tab 2. If I send a message from the first one, hi from client 1, send, I get it back, and then the other user also gets it back. We have created a real-time chat. This guy can send hi from client 2. It comes back to me. I also send it. I also get it back. Other guy also gets it. This is how you can do two-way communication. I am sending messages to the server. Server is responding back to me. Server is also sending the same message to another client. Very common way to build a multiplayer game, a multiplayer chat system, so on and so forth. Is this clear enough? Because if this is, then we'll be moving to something more interesting. Are we good to go, guys? Do we understand this? Oh, not a lot. Okay, we will take a pause. Let me answer a question. I'm sure there's something obvious I'm missing. What's up? I'm looking at Q&A. Not working in Express. Not able to do this in Express. Export is not working. Recap. All right. Let's first try this in Express. Let's go back to this thing right here. Let's copy the code. I did not test this. Oh, no, I did not test this, but I think it should work. Let's see. Let's copy the Express code. Let's paste it here. Let's run a npm install Express and at types/Express. Let me run tsc-b to compile the code. Let me run node dist/index.js to run the code. It's a long running process. It is running on port 8080. It might not work. I did not test this. There's a good chance it doesn't work. If I connect, it does say connected for me. If I go to the other one, connect, it does say connected for me. I get back a hello message from server. Let me send. Oh, it says disconnected. As soon as I send a message, an exception comes. WebSocket is not defined. Let's see. There you go. It does not work because there is a bug. What is the bug? WebSocket is not defined. Can you import it? Yes, sir, Kirat, we can. Should it work now? Probably should. This was never defined, which is why, you did not sort of, this line sort of crashed. I just imported it from WS. I think this is where it comes from. Let's try that one more time. Connect. Hi from client 1. I get back hi from client 1. Other person also gets back hi from client 1. So what was the bug? When I was copying code around, I forgot to import this from the WS library. Other than that, does everything remain the same? I import Express from Express. I create an HTTP server. Forget all the other logic I have written. Just focus on these 4 lines. app.get / rest.send hello world. Very simple Express application. Remove all WebSocket logic. Import Express from Express. Const app equal to Express. If there's a get request here, send them hello world. And then app.listen 8080. Don't even worry about assigning it to a variable. Simple stuff. Done this many times. If I start this, what happens? Localhost colon 8080. If I go, I get back hello world. If I go to a random route, it says cannot send a get request to /ASD. If I go to this, it says hello world. Very simple HTTP server using Express. Now what do I say? I say, I will also create a WebSocket server. Const WSS equal to new WebSocket server, where the server is which one? This HTTP server over here. Given that we have this HTTP server, you write this logic. You only have to write this once. I know this can be a little jarring, but eventually you will see, okay, whenever we create a big application, let's say we create a game, then you just send this request to another request handler. This much is your code usually, data, something like this. And then, request handler exists someplace else. So your boilerplate code is this much only. Your request handler has the meat of your logic. Okay, if the message was, move, if this is a real-time game, if you're creating something like this, the message that the client will send you will be something like, okay, I have moved up or I have moved down. So, your request handler will have all the logic to handle it. Your index.ts file won't look this big and ugly. But since right now we're not writing any application logic, we're creating a simple chat app. This is what we've written. Whenever there is a connection, if there's an error, log the error, remove this. Whenever there is a connection, control should reach here. What does control should reach here mean? It means your JavaScript thread will reach over here and it will have access to a WS variable. Anytime there is a message from that client, control will reach here. You don't have to do anything complicated. Simple. I received a message from the client. That's all. And you just log it on the server. You don't send it back to anyone. If the user sends me a message, server logs it and then remove this as well. Let's create a very simple application. Let's create something like lead code where the user, rather than sending you messages via HTTP, will now send you a message via, this message layer. So less than 19 lines of code. But Kirat, why would the user do this in lead code? Why would they not send a get request or a post request? Theoretically, I get it. They would not. They shouldn't send. They should probably send an HTTP request. But let's say you want them to send whenever the person is on lead code and the person is solving a problem and the person clicks on the submit button or run button, you want them to send the data from a WebSocket connection. Theoretically, let's say. Then we're just logging it right now. Of course, eventually you would put this in the database, do a bunch of things, but we are just logging this. This is very simple WebSocket logic. Create a WebSocket server. Whenever there is a connection, for that specific connection, whenever there is a message, log it on the server. Let me try to compile and run this. Try to go through this and marinate this code, specifically these 6 lines of code, for like 15 seconds. Then let's try it. Then we'll do another poll. This does not really use the power of WebSockets. It's not doing server-side events. It's not pushing data from the server. But you can always write that logic, okay, ws.send whatever. But cool, we're not doing that right now. Simple, straightforward. Just receive messages from the end client, log them on the server. If I run this code now, let me put this in the left, put this on the right. If I go here and connect, anytime I send a message, it gets logged over here on the server. Send messages, server is logging them. Very similar to HTTP. Only I'm not sending a new HTTP request every time. I've created a single WebSocket layer. If I disconnect and reconnect, go to the network tab, I have a single WebSocket connection. And as I send messages, let me send a few messages. I'm sending all the messages over the same WebSocket connection. I'm not doing a fresh handshake every time. I'm not sending multiple requests. Single request mein I'm resending data again and again. And what is the server doing with this data? Right now it's just logging the data. Can it do more? Yes. It can respond back to the user. It can send messages to other WebSocket clients that are connected. It's not doing any of that right now. But do we understand WebSockets and implementation in Node.js? %, 83%. Good, not great. But as always, 15-20 more minutes of class, then questions at the end. So let's try to wrap up because there's not much left after this, I think at least. So give me some time to wrap this up and then I'll take questions at the end. I'm sure if you go through the recordings, you'll be fine eventually. Okay? Let's go through the client side code next. And then, as I said, questions from 8:40 onwards. I think we'll be done with the next 20 minutes or so. Cool. Let's proceed to the client side code. Given you have a server, as I said, the server can be connected from a browser. Let's say, a React app or a Next app, or from Postman, or the thing that we just connected from Hopscotch, or from a mobile app. Question is, how does a React application connect to the server? How can I create a game very similar to, Gather.on? How can I create a chat application very similar to any chat application you might have seen in the past? The answer is, as I said, when you create an HTTP server, when you created an HTTP server, how did your browser talk to it? How did your React code talk to it? How did your normal HTML code talk to it? Harkirat, I used the fetch API. The browser provides the fetch API, or we use this library called Axios, which also under the hood uses the fetch API. So Harkirat, for HTTP connections, I use the fetch API. And similarly, if you have a WebSocket server, you can use the WebSocket API. If you search for WebSocket over here, it already exists. It gives you very nice constructs to connect to a WebSocket server. Let's see how that happens in a React application. For a React application, let's quickly initialize one. First, make sure you have a Node.js server running locally. Make sure you have a Express server running locally, preferably an Express server that, has the same code over here or over here. If you're using this code, make sure you import WebSocket from the WS library, or you can use this code as well. Copy that code and paste it, restart the WebSocket layer and create a React project. Maybe right next to it. Maybe not. Right next to it is fine. Just create it, create a fresh project, create here, does not matter. The reason I don't want to create it separately is because if you close this, then, this will also close. So yeah, pick and choose how you want to do folder management, but I am just going to create it inside the backend project, which is something you shouldn't do. You should have, a root folder which has the backend code and then the front end code, mono repo style. But what am I doing? Let me also do that. That's fine. Let's start the WebSocket server in a terminal. Let's start it in a separate terminal so that we can open the React project here. So let me open a terminal over here. I am already in week 9 WS. I'm going to start the WebSocket server here. The WebSocket server is running. Now I will create a fresh React project in a different folder and open that in Visual Studio Code. Hopefully that is clear. This one is running the WebSocket server. Let it run because we have to connect to it. Backend is running here. Front end we are going to create now. So first create a fresh React project. npx create Vite at latest. npx. I think it is this. I could be wrong. It is something else. What is it? npm create Vite at the rate of latest. My bad. npm create Vite at the rate of latest. We'll create a fresh React project. Call it React WS. I already have that. So let me name it React WS week 19 and select React as the framework that you're using, TypeScript as the language that you're using. Let me go to React WS week 19 and open this in Visual Studio Code. Would urge you to do the same. Create a fresh React project, open it in Visual Studio Code. Then run npm install to make sure all the dependencies are installed. You don't see the red squigglies that I see over here. We'll wait for 2 minutes before I proceed. All right. Dependencies are installed for me, but I'll take a break. Let me look at Q&A, just initialize the React project until then. How to persist socket data in DB? Example, persisting group chats. How do you think? Just store wherever you have the request handler. For example, here you have it in here. Whenever you're getting the data, just do a Prisma call over here. You can optimize it. You probably don't want to do DB calls here. You want to again send it in a queue and eventually, have the database be eventually populated, because a lot of people will send chat messages. You don't want a lot of DB calls. You probably want to bulkify the DB calls. So you can do a bunch of optimizations, but the simplest approach is do a db.store over here. How are we differentiating every user? You don't care about the platforms they connect from. Every client, you will have a client ID. You will have a, this client.id, a way to identify them. They might send a first message that shares their cookie, shares their token, so you can identify them on the server. And then, eventually, every other request you can identify. So this is this person. We will not be covering Next.js. How does Hotspot know to subscribe on messages to send the messages? I think you are coming from the Socket.io world. Question that you're asking is, how does it know the message, it needs to subscribe on messages? This is the only thing that WebSockets send. You send a type message, you get back a type message. You can't change this to, event 1, event 2, like Socket.io you can. So I think the reason you're confused is because you've used Socket.io in the past. Both you send the callback says any message that is coming will come here. And whenever you send back a message. There is no different types of way to send, very similar to Socket.io, where you can be like, socket.on A, socket.on B. Can't do that here. How can I send messages to the specific user like WhatsApp? Yeah, you iterate over all the clients and then, find that specific client and then do a client.send for that user. Eventually, this will come in some project. This will come when we build whatever, Zerodha, you can get this question will get answered there. All right, cool. Can I proceed? Do you have the backend running locally? Do you have a simple React project started locally? Are we good to go? Okay. So whenever you have a React project, what do? We go to app.tsx and remove everything. Sabse pehle to we don't want any random logic here. Then we do put routing over here. We have React router DOM, all that jazz. We're not going to do any of that today. We'll put everything in app.tsx. Ideally, you should have a chat component if you're creating a chat application. And there you should create the socket connection. I'm just creating everything here. Create a state variable called socket. You don't really need it right now, but let's create it. Socket, set socket equal to useState null. It is null initially. Harkirat, why? Why is it null? We'll see. Well, very soon we will see. Initially it's initialized to null. And you can also be like, if not socket, then return loading. So that while the socket connection is being generated, the user sees a loading. And then create an effect at the top, a use effect that runs whenever the component mounts, which means, the first time the application mounts, to create the actual WebSocket connection. Const socket, AI is helping me out too much here, but chalo. Yeah, there you go. I'll go over it one by one. Let me just type it out myself. Const socket equal to new WebSocket. Harkirat, where is this coming from? You did not import it. It is natively present in the browser APIs. Just how you never have to import fetch whenever you're sending a fetch request, you don't have to import WebSocket. Harkirat, I had to import Axios. Yes, Axios is an external library that you have to import. But fetch you don't have to import. WebSocket you don't have to import. You create a WebSocket connection, and then what do? Socket.onOpen. When the connection gets completed, you have an open connection. We're just logging connected. You can do a bunch of things. You can, ideally here you should do set socket. You should set the state variable here. Okay, now you are connected. Now the loader should go away. The user should see a loader until the socket connection is actually open. If I do this, if I do a set socket outside, then the effect will run even when the socket is not open. The user will see the final page. Shouldn't happen. User should see the final page only when the socket has been open. So you can ideally say something like this: connecting to socket server ... something like that. And when the connection opens, you actually set the socket variable. You will see a type error over here. The type error says argument of type WebSocket is not assignable to parameter of type set state action null. It's basically saying, yaar, you told me the type of this is null. How are you trying to set a WebSocket instance on it? And the answer is, whenever you're creating it, you have to pass the types that this can have as a generic. This can either be a null or can be of type WebSocket. That is how the red squiggly will go away here. Whenever you're initializing useState, you can pass the types that it can become. It can be null or it can be WebSocket. It is initialized to null, but eventually gets set to socket. Whenever the socket is open, you log connected, and anytime you receive a message from the server, you log message received. Harkirat, you have written the logic. Okay, when the server responds, we log something. How can I show that thing? You can just put it in a state variable, right? You can be like const messages, set messages equal to useState empty array. And then whenever you receive a message, you can be like set messages m ... m message.data, something like that. What did you write over here? Basically means append to the set messages data. If you don't understand this, you can also just be like, const latest message, set latest message equal to empty string. And anytime a message comes from the server, you can be like set latest message, message.data. Whatever data came back, I'm just going to set it in this state variable. And let me write this state variable here as well. Latest message can be rendered over here. initially it will be empty, but as the server responds back with more and more messages, when does this run? When does the control reach here? The control reaches here when the server sends you a message. Very similar to when we were on post woman. Oh, it went away. But when we were on post woman or hopscotch, we were seeing a bunch of messages here, right? If I connect, the server is down, Node.js. If I connect, I got a hello message from server. Whenever I receive these messages from the server, control will reach here on the client. On hopscotch is also a client. And what does this guy do when it receives a message? It puts it here in the queue. What do we do? What does our browser application do? Whenever we receive a message, we set it to a state variable, which gets rendered eventually over here. So that is how you create a simple application. Harkirat, you have written the logic to receive messages. How can I send messages? You have access to the socket variable. You can just be like, have an input box followed by have a button that says send. And you can be like on click equal to socket dot send whatever message you want to send, whatever is the input body here, or hello world. So that is how you can send data from the backend as well. Sorry, the front end as well. This is how you can receive data from the front end. So if you look at the whole code one more time from the top, I initialize a socket variable. I added some extra types over here to make sure we don't have any red squigglies. If you're using JavaScript, you don't need to add this. You can also always just use the any type if you don't understand this. Then we say initialize it to null. And while this is null, if not socket, the browser should say connecting to socket server. The user should see a loader. Okay, we are still connecting, wait. Then we have a use effect that says anytime the component mounts, create a fresh WebSocket connection. And anytime it opens is when you actually set the variable. Okay, why the socket connection has opened. Now we can get rid of the loader. Now we can show the user an input box and a button where they can start to send messages. If you don't do this, then the user will try to send messages and it will throw an exception. I haven't yet connected. The connection isn't open. So we make sure only if the connection is open, we set the socket variable. I can remove this last line. And then whenever we receive a message, currently we just log it and set it to a state variable, which eventually gets rendered here. So as the server responds, my user will see the latest message. Let's see this in action. npm run dev. If I open this, it shows me the message. Hello message from the server. Harkiya did not show me the loader because the socket connection got created immediately. If I add, some artificial delay here, set timeout. Oh, you can't await here. You get the idea. If I add a artificial delay here, if this takes a really long time, if on open takes a really long time, then you will see the loader over here. Since it's on my local machine, the WebSocket server is on my local machine. It happens so quickly that you don't see a loader over here. I can send messages by clicking on send, and whatever message I'm sending, the server is responding back with a hello world, which is why I see hello world over here. Harkirat, where is this logic? If I open, what did we write? We said, whenever there is a message, client.send back data. Oh yeah. Send back the same data to the user. And what is the user sending? Currently the user is sending hello world. How should you update the application? You should, add a third state variable. Call it const message, set message. Use state empty. And then anytime the input changes, on change equal to set message e.target.value. And then socket.send should say message. Send whatever is in the input box. Whatever is in the input box, send that to the server. The server will respond back with the same thing. And you will see that, in the state variable. So if I save this and refresh now, my server died. Let me restart. Refresh. I see one client has connected. Let me connect another client. Let me open this in another tab. I have two clients connected. Let me send hi there from here, hi there from client 1. Send. I get back hi there from client 1 here. The other person also gets hi there from client 1. So the message is being broadcasted to everyone. Have I created sort of a chatting system? Yes, I have. Send some message, comes back here as well. That is how you write client side logic. In React, very similarly, you can write it in a simple HTML CSS app. You can write it in Next.js as well. The one thing you should do is, clean up in the effect, do a socket.close here, because when you're running React in, strict mode, this gets run twice. What if this component gets unmounted? What if the user is on your website and they go to a different page, the non-chat page? The WebSocket connection should close then. So that is why you should do this cleanup as well. But that's pretty much it. I'll take a pause here. Do we understand how to add it in React? Because if you understand this, adding in Next.js is a piece of cake. We do understand this. Beautiful. So we're at 8:33. We can actually go through Next.js, but we can also answer questions because Next.js is fairly simple. Let me take you through it really quickly. In Next.js, just create a fresh Next.js project. Update page.tsx to be a client component. The only thing you have to make sure is, if you are using WebSocket logic, make sure it is a client component. Why, Harkirat? Because if you don't make this sure, your next server, I repeat, this is your next server and this is your end user client. Your client will be like, okay, can you please give me my landing page? If you don't make the specific component that is using WebSocket a client component, what will happen? Your next server will create a connection to the WebSocket server. We don't want that. We want the end user to create a connection with the WebSocket layer. So the only thing you have to keep in mind is, especially if you're using, client server components, is make sure it's a client component wherever you're creating a WebSocket connection. I did not try this without a client component. If I had to guess, one of two things will happen if you don't make it a client component. Either Next.js will complain. It will be like WebSocket is not supported on the Next.js server, or it will create a connection between the Next.js server and the WebSocket server. If someone has tried that, let me know what happens. But yeah, other than that, everything is exactly the same. Your page.tsx has logic that looks like this. You can have an effect that, creates this. There was another call out here. Okay, you can actually convert this to a custom hook called use sockets. Something like this, function use socket, to make your logic slightly cleaner. Yeah, the only problem there will be, how will you set the state variable? Maybe you cannot do this. Yeah, you can basically do something like this, and then, yeah, this will be somewhere else. You can create a custom hook called use socket, which has all of your, use effect logic, socket initialization logic, returns the socket, and you can simply be like const socket equal to use socket over here. And then you can add an effect over here that does this socket.on message, do whatever you want. So, but yeah, I'll pause here. The only thing that's left after this was scaling WebSocket servers. It's fairly straightforward. Whatever you think from first principle is the right way to do it. This was done at GatherTown. This was done at Backpack when we had chat. This was done at Backpack Exchange. This is, how you scale WebSocket servers. You scale them horizontally. The thing about WebSockets, if you have 1 million users, Mano, this is 1 million users. How many HTTP servers do you need to support them? Not a lot. Why, Harkirat? Because not 1 million of them are sending requests together. Maybe 5,000 are sending requests together. If there are 1 million users currently active on leadcode.com, not everyone is sending a request. I sent a request initially. Now I'm just chilling. I'm just, scrolling the page. I'm not sending any more HTTP requests. Whenever I change the page, I will send some more HTTP requests. So scaling HTTP servers is much easier. You don't need a lot of HTTP servers to support 1 million users. But if you have 1 million users in a real-time application, but there are WebSocket connections, then your server fleet needs to, be connected to 1 million users. A single server won't be able to handle this. You are persistently connected to everyone. There are benchmarks around, how much can a Socket.io server support? How much can a Node.js WebSocket server support? I think it's around 10 to 20K users. You can't support more than that. If you have 1 million users and you have a WebSocket server, you will need a fleet of WebSocket servers. A single WebSocket server won't be able to support it, especially if you're using Node.js, where, most probably it will be on a single core. If you're using Rust on, on a 32 core machine, then you probably might be able to support more. But yeah, a single machine running Node.js can only support, 10 to 20,000 users. So if there's 1 million users, you probably need, 50 to 100 servers. So that is how you scale WebSocket servers. The problem comes when these sessions are sticky. I repeat, when these sessions, these are 1 million users, first 10,000 users are connected to WS1. Second 10,000 users are connected to WebSocket server 2. Third connected to WebSocket server 3. Now let's say this guy sent a chat message. This guy sent, "Hi there," and one of his peers in the same room is on another server. There is one user connected to WebSocket server 1, another user on the same room connected to a different WebSocket server. How will you transmit the message from here to this WebSocket server back to this user? I repeat, if you have sticky, or if you need sticky connections, what are sticky connections, Harkirat? There might be, 50 people in the same room. Sticky connections means you will make sure even if there are multiple people, one present in India, one present in US, one present in UK, if they are part of the same room, if they are part of the same, you can go to gather.town and create a room for your team, your company, and all those people will be part of the same game. I hope you understand what a room is. It's like a chat room. It's a place where messages need to be transmitted to each other. For example, in this room, there are 1, 2, 3, 4, 5, 6, 7 people. One of them is a Sardar, so cute. So we have 7 people here. All 7 people can either be part of the same WebSocket server. Believe it or not, that is how it happened at Gather until I was there. Whenever a new room was created, all the users were connected to the same WebSocket servers. It was known that they don't support more than 200 users. A single WebSocket server can support 200 users. So, they would create sticky connections. Doesn't matter if you're from India, US or UK, you will all connect to the server in UK, let's say. This is one way to scale WebSocket servers. This is called sharding. You are sharding the users. Based on your room, you will be connected to the same, WebSocket server. And we don't want to horizontally scale this. And, that will just complicate things. So if you're in the same room, you're all connected to the same server. This is one ugly way to scale WebSocket servers, by sharding them. By people in the same room connect to the same server. What is a better way? Doesn't matter what room you are in. Doesn't matter what room you are in. If you are in UK, you will connect to the UK server. If you are in US, you will connect to, let's say, the US server. And if you are in India, you will connect to the India server, even if you are in the same room. This is a better way to scale. What is the problem in this? The problem is, if I move up on this Gather Town page, if I move from here to here, this message needs to go from me in India to my server in India to a server in the US to my peer who's connected to the same room in the US. Needs to go from one WebSocket server to another, which is why this is harder to scale, but the better way. Why is it better? Because I can be close to my India server, US person can be close to their US server, UK person can be close to their UK server, and you can scale beyond 10,000 users. If you have sticky connections, if you're putting everyone in the same room on the same server, you are restricted by 10,000, that number. You cannot have more than 10,000 people in a single room. But if you want to have a very big application with 1 million users in the same room, is when, this architecture works better. Harkiyat, how would this architecture work? There are multiple ways. The most easiest one is you create a pub sub. Whenever a person from India connects, they tell this server, hey, I am part of room 1. WebSocket server tells the pub sub. Pub sub stands for publisher subscriber. We'll probably discuss this today. It tells the pub sub, bhai, I am subscribed to room 1. If someone sends you a message on room 1, tell it to me so I can forward it to Harkirat in India. And let's say Alex connects from US. The most American name I could think of. And he also says, bro, I am part of room 1. Now, anytime Alex sends a message to the second WebSocket server, the WebSocket server publishes it to the pub sub. And then the pub sub is like, Acha, who else needs the messages from room 1? India server, you need one? There you go. Alex has sent hi. And then the hi reaches here. And then you send it back to Harkirat. That is how you scale horizontally the better way, by not using sticky sessions. Both are fine approaches. Gather was valued at $1 billion. Still use it, the sticky approach. It worked for Gather because, there was a very big restriction of 200 people per room. Because if you have more than 200 people, it's very hard to support audio. And this app supports audio as well. People can talk to each other. So for them, it made sense. But if your application needs to grow beyond 10,000 users like Discord, then you probably need, a distributed system that's non-sticky. But with that, I will do a poll and then I will answer some questions. That was probably the class for today. Tomorrow, let's do message queues, pub subs, create some, maybe try to create a system like this. But yeah, all right. That was pretty good. 92% is great. Let's look at Q&A. I'll just open chat, I think. Please share code of WS in React. It's right here. Create a fresh, I can push it to GitHub if that's what you want. But yeah, it's right here. Just create a fresh app and then, replace app.tsx with this code and you're good to go. All right, I'm going to open chat. Let's just answer. Easier to track questions there. All right, any questions, guys? A lot of questions. We'll wait. And okay, let's see. Notion doc. Mine is disconnecting. I'm trying to use HTTP only on Hopscotch. Do you see any server logs? Is your port correct? How else can you debug? If you look at the server logs, is your server crashing? Most probably it might be. I missed some classes about this Web3 cohort. Where will I start? Unsure right now. Why are you dancing so much today? I don't know. Am I? How it works in group in multiple users? What does that mean? Can you elaborate on the question? Should we learn about Socket and WebSockets? Is it not worth learning Socket.io? There's nothing to learn in Socket.io. If you know WebSockets, you'll understand the code of Socket.io, vice versa. So both are fine. How do I create rooms and one-on-one connection between two clients? Yeah, so as I said, Socket.io lets you create rooms very easily. This does not. If you look at the socket code, especially, the server code over here, there is no easy way for you to create rooms. You have all the clients, like all the people currently connected on the wss.clients array. But, you have to tag them. You have to maintain a global variable that will store this client is in this room, this client is in this room. If you want to look at a repository, we actually did this in a YouTube live. So if you go to real-time chat app, you will see the index.ts has, a user manager. You create a user manager class. This is like a little too optimized. You can just create a global array or global object where you store, this user is part of this room. This user is part of this room. And then you broadcast the messages correctly. If you want to look at some code, this is the code. It will be hard for you to understand if this is the first time you're learning it. But this has, a lot of the logic that you're looking for. How to create rooms or, one-on-one messages. Notion doc. Can I create rooms and one-on-one answer that? How to make project from React and Node.js? How do I find ad hoc startups? How much the price of Web3 code? Price, I don't know. How to make projects from React and Node.js? How to find ad hoc startups? Ad hoc startups usually come on Twitter, and projects. I'm assuming your question is how do you find projects? I don't want to name one, but मैंने कई बार बोला है. There aren't a lot of people on the call. Dub.sh is a great one to look at. That guy's also pursuing it full time now. I don't know if he's hiring, but that code base is prime. If you look at that code base, that's pretty good. And then, a lot of code that we are writing is also, the same that's written in a lot of companies that use that specific stack. Lua file for NeoVim, I made 0 changes from LazyVim. Exactly the same. I'm about 20% your coding speed. How to Grow coding speed. So yeah, it comes from a lot of practice. Write a lot of code, and it naturally comes. I've never used type racer other than with friends. There's no hack around it. You just over time it happens. WhatsApp clone. I'm probably one of the best clones for WebSockets. WebSocket versus WebRTC depends on the application. For example, if for Gather Town, as people are moving around, people move around very often. This person might move around everywhere. Does it matter if a few events get missed? What if this person moved here, and a few events got missed in the middle? It's fine, because as long as their eventual location is transmitted, it's fine if a few events get missed. So for an application like this, WebRTC might work. Why? Because WebRTC happens over UDP. It can happen over TCP as well, but UDP, you can send it over UDP. The benefit of UDP is it happens faster. The downside is a few events get missed. But does it matter if this chat bubble that's coming on top? Does it matter if you don't see it? Doesn't matter. So, it is a choice. You would use WebSockets when you need TCP, when you need to make sure the event goes to the other place, like a chat system. You can't miss a chat message. But can you miss a movement message? Yes, you can. If the person is moving around very quickly, send all the data via UDP or WebRTC. When they stop for more than 2 seconds, then send the final message via TCP or WebSockets. And that's, how you can decide whether to use WebRTC or WebSockets. More questions. I'm looking at the Notion doc very soon. Notion doc. Answered the room's question. Can we spoof messages event sent to client another way? Can we spoof message event? No. Also run you can just how you create an HTTPS layer on top of HTTP on EC2 machines on AWS. How did we do it? By creating an Nginx server that has your certificate and runs on HTTPS. I have not done that video. Certbot video I haven't done, but just how you convert an HTTP server in Express to HTTPS, you can convert an HTTP WebSocket server to HTTPS. The steps are exactly the same. How does a game like Counter-Strike or FPS work? Great question. There is one extra thing that happens in these games. Everything else is the same. If there are 100 people currently playing Counter-Strike, firstly, they have sticky sessions from what I know. Why do I know this? Because, a few friends used to play it in college and they used to say, bhai, maine server bana liya. I have made a server is what they used to say. So I think there is the concept of a sticky server. Whenever you're playing Counter-Strike, everyone is connected to the same WebSocket server or, real-time server. Maybe they don't use WebSockets, they use something else. But everyone is connected here. The extra thing that happens is there is some game logic on the server. I repeat, the server itself stores, when you send it a message, right, I am moving up, I am moving forward. The server maintains that Harkirat is at 2,3. And then someone else does the same thing. It maintains that Aman is at 2,4. Raman is at 2,4. So on and so forth. Why Harkirat? Why do you need to do this? Because what if the person tells you, nahi, I am at 200,200. They can spoof events, right? So everything needs to be maintained on the server. And especially when you shoot, I repeat, when you shoot someone, I don't know if I should say this in class, when you try to play with someone, whatever, you get the idea, you shoot someone, you send the server the logic, the message that says, I shot person from position 2,3 or wherever you are with this rifle. And then the server will calculate, does this mean the other person dies or not? The server is the source of truth, because you might be on a very bad connection. You might be on a very good connection. What if you send, shoot, but your, opponent moved a bit? Who decides? Everyone needs to have the same state. When you're in Counter-Strike, if there is some latency between this guy and this guy, and you said shoot, and this guy said, Acha, Harkirat shot from this position, but this event reached this client after 2 seconds, then the person would have moved. So this person will feel like, he did not die. This person will feel like he died, so on and so forth. So the one extra thing that happens is the server is the source of truth for a game like Counter-Strike, where when you shoot someone, the server will be like, based on the current positions, this person is dead. And it will tell everyone this person is dead. It will not tell everyone shoot 2-3 rifle. It will not tell everyone shoot 2-3 rifle. It will tell everyone कि a shot was made, whatever, but it will also decide whether or not the other person died. You will not on the client side decide कि अच्छा shot हुआ है तो other person की position ये है तो it will die or not. The logic to whether or not someone has died, whether or not you have picked up a bomb, needs to happen on a server. So yeah, that's what happens in real-time games. When you create real-time games, the only extra thing that happens is your server maintains a lot of logic. Your server is the source of truth on who won and who lost and who shot and who got shot. And your clients never decide that. Your clients are never like, acha, shot happened from here, so I will decide, is the other person dead or not? So the events are a little extra than just broadcasting it to everyone. Good question. You should read about multiplayer games. Most multiplayer games are made like this. How to answer that? Socket.send and client.send in the server code. So firstly, it doesn't matter if you call it socket or client. It's written client over here. You can call it socket. Let me make this even easier to understand. If you look at the WebSocket server, if you ignore all of this logic for now, this WS variable is one thing. The WS variable is one thing. As people connect to you, I repeat, if this is your WebSocket server and this is a client, a browser that connected to you, as soon as they connect, as soon as the WebSocket connection is open, control will reach here. You will have access to a WS variable, a socket variable. You can call it whatever you want. And यहाँ पे you can be like, यार, as the user sends me messages, as the user sends me hi, hello, move up, move down, if this is a Counter-Strike game, control will reach here. I should write logic here to, write to the DB that the user has moved. If this is a Counter-Strike game, if this is a chat game, then write to the DB that a message has been added. That's the logic you should write. What else should you do? You should tell everyone कि यार Harkirat has moved up a bit or Harkirat has given a message. So what do? You iterate over all the clients. There might be other people connected, right? You're not the only person who's connected to the Counter-Strike game. Your friend might be in the same room. Another person might be in the same room. So what do? You iterate over all the clients, ws.clients or whatever the logic was. WSS.clients. You can also maintain a global array. You can be like const connected clients equal to empty array. And then यहाँ पे you can be like, whenever a connection is made, connected clients.push WS. So you can maintain your own global array. You can also tag the users with this person is part of this room, something like this. Okay, the type of this array is WS, the WebSocket connection, and then room, which is string. So as people connect, you can store their WebSocket logic as well as the room they are in. For example, Counter Strike room 1. Not push. Append hota hai kya? Oh, sorry. Array. And then when someone sends you a message, कि भाई, I want to send this data to this room, you can get all the users in that room. कि भाई, connected clients dot you filter all the people in that room or whatever, and then for each, and then for every client you send the message client.send Harkirat has moved or whatever. Client.ws.send. Only if client.room equal to Harkirat room, something like that. So yeah, the client.send or more specifically the ws.send is कि भाई send this user back some data. Whenever someone sends you some data, you broadcast it to everyone. That is what this logic does. Okay, for every connected client, where does connected client get populated from? From a global array that I've created over here. I've given it a type, which is why it might seem difficult to understand, but you can give it an any type. Okay, bro, doesn't matter, very simple array. Whenever someone comes, add them to this specific room, and this can be based on some logic based on ws.current route. You can, like, when the user connects, they can also send you, okay, I want to connect to room number 1 or room number 2. They can send you their cookies. So you can do all that authentication logic here. And then anytime there's a message, you just broadcast it to everyone. Does WhatsApp use WebSockets? I think so. I have read this somewhere. Most probably they do. Like 99% they do. How can we do something similar in Postman that we didn't Postman? I don't know. I don't know if Postman supports real time. Someone told me recently they do. We can try to figure it out. Like, this is how I would figure it out. I would just open Postman. And then, yeah, I don't see anything here. Let's see. Post get. There is a way. I'm sure there is a way. I don't know what is the way, but there is a way. I mean, maybe there's not a way. I don't know. Maybe it happens after you sign up. Lightweight client, explore. Yeah, just Google it. If there's a way, you'll find it. Else just use Hopscotch. Open source repo allow us to look at the code structure of WS if possible. Standard WebSocket in Node.js and in open source repo. I mean, depends on the definition of an open source repo. I showed you the real-time server. That has a pretty decent, architecture. If you want, you can look at it. A lot of this was in Backpack. It got removed eventually, but it won't be here now. But this also had Backpack had chat at some point. A lot of this logic was there. Is there another repository that has WebSocket logic? I can find one. I showed you one already. That's also pretty complicated. If your goal is to learn, so you can just go here and try to look at how user manager, things like these are structured. This is also a lot of code. So yeah, there is a message handler that I pretty much shared. Whenever there is some data that comes in, connection on message, it goes to a message handler that actually checks. Oh, is the type of message join room? Is the type of message send message? Is the type of message upvote message? What we were building here was something like this. We wanted to create a chat system where people can come and send doubts, and then a lot of people can upvote, and the most upvoted doubt is what comes here to this other section that the educator can look at. That's what we were trying to build. So yeah, you can read through this code. Let's say Among Us game chose either server in Asia, US, UK, and they'll join the room, and so that will mean most use sticky connection. Yes, I would assume so. If you have less than 200 users, Among Us has 5 users, you will most probably, there's no point distributing it. That's over engineering right there. If a company that's worth $1 billion is not doing it, why would you want to do it? I'm not saying it's not optimal. It is optimal. The optimal thing is you don't have sticky connections. You have a distributed WebSocket layer. But do you need it for 5 people? No. For example, if you're creating a WebRTC call, if it is between 2 people, if it is something like Omegle, person 1 here, person 2 here, should you use peer-to-peer WebRTC? Yes. Can you create a distributed SFU architecture? Yes. Should you? No. This is good enough. It will give you a lot of benefits. It will give you lower latency. These guys will be directly connected to each other. They'll share video directly with each other, so on and so forth. If you're creating something like Gather Town, where in a single room there are 100 people, sometimes 1,000 people talking to each other, sharing video, then you should do distributed SFU architecture. So it's about the choice that you make. With that, oh shoot, I closed all the Notion docs. Let me open them again. Oh god, Zoom is so hard to navigate. Okay, there you go. REST versus GraphQL. It's just different ways. How does REST work? You send a post request with some body and some headers to the server. GraphQL gives you a different way to send data to the backend, a specified way. Why is it beneficial? It is beneficial because if you're using GraphQL and if you have a lot of relationships in your backend, you don't have to round trip. Okay, what is an example of this? Good example is if you are creating Facebook or even better Swiggy, any application, when the user first comes to the website, swiggy.com, you usually send to the server, bhai, what is this user's details? You get them back. Then you send a request, what are the restaurant's details? You get them back. Then you send a detail, his order history, you get them back. You do a lot of round tripping. Versus, what if you could describe to the server, okay, yaar, I am a browser client. Please give me just the name of the user and the order details, which should have, the order type and the restaurant name, and give me, the current restaurants. Give me their name and their rating. What if whatever client was sending a request can be like, if this is the GraphQL server, can be like, yeah, I need data in this shape. And then, the mobile app might be like, yeah, I only need data in a different shape. I am the mobile app. I don't really need the user to see their order details. So let me just skip this. What if your GraphQL server had a single endpoint that could support both of these, rather than, you creating two different endpoints, one / API / v1 / web, and another endpoint / API / v1 / mobile. You create a GraphQL server. You tell the client, bhai, whatever you want, मुझे ना payload में दे दियो. Give me in the payload what you want. I will respond back with the same. This way you can minimize a lot of the things that the server is sending. If you have a single endpoint that, Harkirat, I will just have a single endpoint, it returns everything. You can. But then the mobile app is getting order details, which it doesn't need. It doesn't need to show it. So this became a problem at Facebook, because Facebook, very big company. Wahan pe they realized that, every client is sort of needs its own shape of data, less data, more data. So they created GraphQL. It just lets the user specify, I want data in this shape. Server responds back without you having to maintain, 10 different endpoints for web, mobile, so on and so forth. Can you explain this? This. What does this say? It says, okay, bhai, ws.on error. If there is an error, call this function. You can either be like, okay, bhai, call this function with the error, which will do whatever. Error came plus error. You can either do this, or you can be like, okay, bhai, whenever an error comes, call this function called console.err. So what will happen? Whenever an error will come, it will call console.err. Rather than calling this function, it will call this function. You can also do this. Look at the function error callback. Rather than doing this, okay, bhai, whenever there is an error, please call error callback. We are saying whenever there is an error, please call console.error. So what will this do? Whenever an error will be thrown, it will call console.error with the error. So it just makes sense to do this, right? Why do you want to create a fresh function which then calls the same console.log or console.err error? If this callback is just going to do this, and the argument here and here are exactly the same, then just pass console.error over here. You don't need to create a fresh function which will get an argument and then pass the same argument to another function. Just give the function name here. It will call it like this. WebSocket connection error. Error मुझे दिख नहीं रहा. Oh, there you go. Disconnected. Sir, you are creating a WebSocket server connection. WSS needs to be WS. He takes a build application called Hello World. Very nice. High level overview about integrating timescale into a graph, fancy loading animations in our Paytm application dashboard. Have you made this? Very cool. Or are you just asking? Either way, high level overview is timescale DB is a place where you can give time series data. At this point, this happened. At this point, your portfolio value was XYZ, so on and so forth. And you can also tell it, here maintain a 24-hour chart, maintain a 3-hour chart, maintain a 1-hour chart, 7-day chart. And it will cache all of those values for you. It will store them, in various databases or tables. Okay, this is the 24-hour chart for Soul. And this is the whatever, 1-minute chart for Soul, so on and so forth. And then when the user asks, because eventually the user will come to your, website like this, and they might be like, or a better example here might be CoinMarketCap. They come to your website and they might be like, I want to see the 1-day data. I also want to see the 7-day data. Okay, it looks like this. Let me look at the 1-month data. Let me look at the 1-year data. So you don't want, there's a single database that has all the entries. You want to have a 1-year database, a 1-minute database, a 7-day database, so that this data is cached. You just get it from there. That is what time scale or other time series data databases help you with. Please do the code 100 or join, but I can't go. That makes sense. All right, more questions, and then we'll. Oh shit! It's 9:07. I have to rush. Notion question 1, Notion doc 2, doc 3. All right. Apart from early stage startups in JavaScript TypeScript, is used in the industry in large orgs. And depends on the definition of large org. It is definitely used in front end everywhere. If you join Google, if you join Amazon, if you're writing front end code, you're using TypeScript. Back end code is tricky. In enterprise companies, probably not. I mean, we use a little bit of it in Goldman. So, it is very nuanced as to which company uses it, which doesn't. Java is more popular in enterprise companies, but big companies, for example, depends on the definition of big, right? Gathertown is big, $1 billion, but it does use Node.js. A lot of companies, are not worth a lot of them, still use Rust. So it really depends on the founding team usually. Is jumping between technologies doable? Yeah. I don't know why people worry about this too much. It's very easy to pick up a new stack. If you're very good in one, then you'll very easily be able to move from one to other. Most organizations have, most startups do. Organization is a big thing. Most important. How do you build your connections if you can't go to conferences? I never go to conferences, just in case. I go through a lot of open source code and talk to people there. It's very hard to reach a Bollywood celebrity. It's very easy to reach a coding celebrity. If you contribute to their code base, if you contribute to Linux, probably able to reach the maintainer of it. If you contribute to Ethereum, you'll probably be able to talk to Vitalik. So it's actually, that's the best part, right, of tech. Okay, the biggest celebrities are actually very achievable, provide you code. And I hate going to conferences. Can you please give an overview of the graph section is built? The graph. Most apps like these use something called TradingView. So TradingView provides an API for something like this. No one's building this in-house. It's very hard to build this in-house. So yeah, and this has a very clean, easy API. They have a premium version, a free version to do this. So yeah, the graph is actually for a trading app like this delegated to trading. Everyone, I think, including maybe not Zerodha, but like most of them use this. How do you learn a new technology? New tutorials and courses available? Yeah. So this advice remains very concrete from my side. Okay, you learn a new technology by building something big in it. If you're lucky, you will find a company that's building something big in it. For example, if you want to learn AI, if you're lucky, you'll join a company that's early with very smart people who are building it, and everyone's figuring it out. It's not like there's a playbook for anything. How do you build a AI agent or whatever, a co-pilot thingy? There's standard guidelines how you would build it from first principles. You will learn it very well if you're working at a company that's doing it and it has founders that have background in it. So that's probably the best answer I can give. That's the best way to learn. But I get that not everyone can have that opportunity. But then the second best thing is just looking at open source projects and trying to solve issues there. What's the difference between WebSocket server and WebSocket client? What is the difference between Express and Fetch? Express is a library you import on a server. Fetch is a request you send from a client. So what is the difference between a WebSocket client? It gets initialized in the browser. What is the difference? What is the WebSocket server? It gets initialized on the server. What is sticky connection? As I said, sticky connection is if you have a fleet of servers. If you have multiple WebSocket servers and you have a restriction, your users in room 1 need to go to WebSocket server 1, then your connection is sticky. You need to make sure, if all of this is in front of a load balancer. I repeat, a lot of times you might have a load balancer. You don't give the end user, 3 URLs, ws1 dot something, ws2 dot something. You give them a load balancer URL, ws dot whatever, randomwebsite.com. Your load balancer needs to make sure request is coming for room 1. I need to send it here. If someone is connected to room 2, then where are all the room 2 connections? They're on WebSocket server 3. I need to send it here. So on and so forth. That's what a sticky connection means. In the real life transaction, you said message would be broadcasted to everyone. I'm confused because message should only be transferred to recipient, right? No. If you have a chat application, if this is my chat interface and I type hi there over here, this message should reach a WebSocket server and it should get broadcasted to everyone who's part of the same room, right? If someone else has a mobile app, they need to see your hi there message over here. And then if someone else has it, they also need to see it. So it needs to be broadcasted to everyone. What makes you think it does not? Can you answer that? Same question someone else asked. I have to think about this now. Okay, cool, chat. Okay, I'll open it one more time, guys. I have a hard stop in maybe 5-10 minutes, but happy to answer quickly a few more questions. What is the difference between polling and DDoS attack in terms of handshake pattern? तो बहुत ही अलग चीजें हो गई यार. Polling is when there is nothing malicious in polling. If this is a WebSocket server, one of your browser is sending request again and again. This isn't malicious. This guy is just like, if you're on lead code, you're just asking, is my submission done? Is my submission done? There is nothing distributed about it. DDoS mein, what is the biggest word? First D, distributed denial of service. Harkirat, why is D very important? Because if the same person sends a lot of requests, you can rate limit them. You can be like, sorry, you've sent too many requests. When there is a distributed attack, when the requests are coming from various IPs all around the world together, is when it becomes a distributed denial of service attack. Here you maliciously send requests again and again and again. That is what DDoS is. What is polling? Yeah, can I get some data? Okay, cannot. Can I get some data? Okay, cannot. You're not distributing and targeting a server. You're just trying to access their servers. You are being a little impatient and sending a lot of requests, but that's fine. You can always be rate limited. When you do a distributed attack, it's very hard to rate limit because messages are coming from so many IPs. So, that's why DDoS is different from this one. Oh shoot, I lost my chat. Also, I'll stop sharing. Can we please skip 1 week class? If everyone, I think I'll do a poll. I think most probably people will select, let's skip it. Yeah, before 1-200, we will do it. Even though this is like sort of the beginning of 1-200, but yeah, I think next week will be a holiday most probably. We'll do a poll. There you go. Postman supports WebSockets now, so you can read at that blog post. Honest feedback, please consider. Let's consider. Static site generation with dynamic routes. Yes, I read this. Someone posted this, which leads to this. To cache dynamic routes during build, added this. Does not cache for MCQ or code type questions. Problems, only Notion blogs. That makes sense. Oh, you added a code. Can you just create a PR actually? And also, like, can it not do it for MCQ questions? Can you not have a part of the website statically generated? The answer could be no, but I think you can. I could be wrong. Okay, if this is an MCQ question that I open, also just create a PR and happy to create a bounty for this. If I open this page and it has an MCQ and the right side is dynamic, the left side is not dynamic. Can you statically generate the left side? The answer could be no, but I think you can. Let me know either way. Feedback. The key to learning is feedback. Bhai sahab, public feedback. I'm just trying to decide to move forward, but sometimes it creates ambiguity. Regarding DSA polls, 60 online classes, recording of the creator. But Harkirat shows bad quality Zoom recordings are the worst. I know. I don't think I'm doing this. This is the first time I will not follow polls. And for two reasons. Number one, yes, very hard to Zoom recordings are a pain, especially if it's a recording of a live class. To understand, I don't think anyone will go through this. Yeah, exactly. I get your point. And the thing, it's not happening. The second thing is it's very expensive. It's almost 7-8 times expensive to get a cohort from someone versus just getting an instructor. And I'd rather spend that money on bounties. I think this is a web dev cohort. If we are going to burn money, rather burn it on something that helps everyone learn the thing that is the goal of the cohort. DSA is something extra. I think a small population might might help out from Soham's course, especially college student looking for C++ classes. I think that's why, but yeah, I get your idea. Rectangle is more as useful. Let's call back. Yeah, look at that. Cool. All right. What happened to the merchant app in the Paytm project? If you're completing it, can you please provide the guidance? Yeah. So the merchant app needs WebSockets, which is why we've done WebSockets today. Probably in an offline video I can. There are a lot of offline videos that have piled up. Let me complete them first. And 0 to 1 people can still stay, as I said, until the end of the month. So if you push a little bit more and tag me on Discord, there's a good chance I make a video on the merchant app. It'll be difficult. Like it'll be like 3-4 hour video. Share some Rust resources. The Rust book, best one. Okay, so that. I'm not excited. I just like this, man. It's just easier. I think it's more productive. It's more, something new you learn. Everything else is, everywhere there, which is why I'm a little excited. It's also easier, as I said, because, it's simple stuff. It's not a lot of code, but it's, when we reach Kubernetes, you will actually see this. Run 5 commands and you have something running on the cloud, things like these. So yeah. What else? Cool. I think that's it. We'll call it here, guys. I have to meet someone, but this was great. Thank you for joining. Let's do some more pub subsystem messaging queues tomorrow. All right. See you guys. Bye-bye. I am recording. Cool, guys. I'm a little, not too much, but a little under the weather. So we'll see how long the class goes. Today's class, if you've not gone through yesterday's class, it'll be slightly difficult. I wouldn't say it'll be too difficult because, we'll be reintroducing everything. But this was yesterday's class on Advanced Backend Communication and Websockets. Today's class is on, we need better search over here. Today's class is on Redis, pub subs and messaging queues. So let me share the link to the slides. But yeah, if you did not go through yesterday's class, today's class might feel overwhelming at some points, but I'll try to take everything from the basics. Just to give a brief about yesterday's class. Yesterday we understood how do you do advanced backend communication. More specifically, how does one backend system talk to another backend system? This is something we did yesterday. I sort of introduced pub subs as well as messaging queues yesterday. Today we're diving deeper into pub subs and messaging queues. What did we discuss yesterday? HTTP we already know. WebSockets we discussed yesterday, even though WebSockets aren't really used for backend to backend communication. They are usually used for front-end to backend communication. Pub subs and message queues are almost always, always used for backend communications, for two different backends to talk to each other. You will never have a browser over here publishing directly to a pub sub. You will never have a browser, most probably, unless I'm missing some very weird use case, publishing directly to a message queue. It is for communication between one backend and another backend. Harkirat, can you give me an example? We gave 2 examples yesterday, a Paytm example and a lead code example. Today, we will dive deeper into the lead code example. What are we learning today? We are learning queues, pub subs and Redis. If you want to code along, you will need Docker on your machine because we'll be using Docker to start Redis. So if you don't have Docker, might feel a little, you might not be able to code along. You can still figure it out by getting a Redis instance online on, Avian or some other provider. But I would just say use Docker because even if you use Avian, you will still not have a few things locally that you might need. So please make sure you have Docker installed. And what are we learning? Queues, pub subs and Redis. More specifically, we are learning how would you build a system like lead code? How would backend communication happen in a system like lead code? Where does a queue come into the picture? Where does a publisher subscriber come into a picture? Harkirat, then why are we learning about Redis? Because Redis gives you a bunch of things. 2 of those things being pub subs and queues. Harkirat, can I do pub subs without Redis? Yes, you can. There are many projects or, libraries or implementations that let you do pub subs. What is the name of that? I'm forgetting. Queues also, there are many implementations. RabbitMQ is a good example of queues. What is a good example of pub sub? Is SNS a good example of pub sub? Probably. Simple notification system. Someone can notify, other people can listen onto notifications. Maybe not technically true. SNS is a service by AWS. But if not SNS, there are various, pub sub implementations. Redis is one of them. Redis lets you do pub subs. What are pub subs, Harkirat? We will get to very soon. Let's understand. In a lead code like system, where do you need queues, and where do you need publisher subscribers. The first part, the final architecture of lead code is sort of complex. This is the final architecture. Before we reach the final architecture that has both the pub sub and the queue, let's just look at a simpler example with just the queue. The architecture says anytime the user is on your platform, for example, the user is on leadcode.com and they try to submit a problem. Let's say I open the toSum problem over here. Anytime I try to submit the problem, a request should go to the primary backend of yours. Harkirat, what is the primary backend? Your Express server, simple Express server that received a request from the browser. Okay, bhai, for problem ID 1, or in this case, it will be problem ID 2-sum. Code is some code snippet. In this case, the code snippet would be this. And then the language in this case is Python. But here, whatever the input might be. This input reaches a primary backend and this pushes it onto a queue. Harkirat, why does it push it onto a queue? We have the code of the user. We should just execute the code of the user here. Tell them the response. Okay, yaar, there you go. Your code succeeded or failed. The problem is, the reason you need to delegate this out is that what if the user sent you a code that's malicious? What if they sent you something like this? While one, or whatever is the way to do while loops in Python, C++, C equal to 0, something like that. What if they sent you code like this? You will take their code, run it on your primary backend. The CPU of your primary backend that is supposed to serve other users is now being used to run the user's code, which is why you delegate the user's code to someplace else. You say, "Ke bhai, acha, your code will run someplace else. Let me take your code and send it to that worker." That is why it says W1 here, because this is a worker node. Why is it called worker? Because its job is to work on something, to pick things, do its thing, and then, respond back, and then pick the next thing, do its thing, respond back, so on and so forth. Hence, usually these are called workers. The primary backend puts this onto a queue. It puts your problem onto a queue and your workers pick problems from a queue. Harkirat, why do you need a queue? Why can't my primary backend simply tell worker 1, "Ke bhai, please execute this code"? That way I have delegated. It is not running on my machine. There is no security issue. The reason you cannot do that is because what if 100 people send you requests? If 100 people send you their code, you don't want to send them to, the same worker, which only has 4 GB space. You want to guarantee, whenever you're on LeetCode guarantees, okay, your code is running on a 2-core machine with this much CPU, so on and so forth. You have to make sure those guarantees are met. You have to make sure every worker runs a single code at a time. And queues become a very popular use case in this case. Here, even if you have only 2 workers and 20 people submit problems, you will have a long queue. And workers will pick them up slowly. A lot of people will be waiting for their response. But you can guarantee that worker 1 will only pick 1 item at a time. Worker 2 will also only pick 1 item at a time. It will run it. It will store the final response somewhere. And then it will pick the next thing. So to make sure you pick things one by one, to make sure if your primary backend is overwhelmed, if everyone is trying to do a very expensive operation very fast, you can smoothen out that operation. Okay, bhai, let me push to a queue. Slowly we will do it. If you submit on LeetCode, take some time, test results, because there's a asynchronous backend process that's processing your code. That is where you need queues. Another benefit of queues is if you have 0 workers, then also at least, people's submissions remain in queue. Whenever you bring up a worker, they start to get picked up. Another benefit is you can auto scale your workers. You can be like, if the queue length becomes 100, I should probably start 20 workers. But if the queue length becomes 3, I should probably stop most of them. Only 1 is fine. So you can auto scale your workers up and down. This becomes super important because in lead code, if there are 100 people on your platform, you don't really want to bring up or keep 100 workers alive at the same time. These are very expensive machines. So you have to make sure you auto scale them very aggressively. Queues are a good use case for it. So that is one place you might want to use queues. Generally, whenever you have an expensive operation that needs to run on a single machine, another good example of this is video transcoding. Harkirat, what is video transcoding? If I go to YouTube and upload a new video, it takes some time for the video to process. I upload a single 1080p video. That video gets converted into 4-5 different qualities. This is called transcoding. This is also a very expensive operation. Here also, you want that whenever there is a user uploads a video on YouTube, it goes into a queue and then workers eventually pick it up and transcode the video. So that is another use case where a queue makes a lot of sense. A good example of queue is RabbitMQ, SQS, simple queuing service in AWS, or Redis also lets you do queues. And the second part that we have to learn is pub/subs. So quickly to revise, what have we learned? Whenever you have users who want to do an expensive operation on your machines, a long running expensive operation, be it submitting a lead code question or uploading a video for transcoding, for converting into 720p, 360p, you probably want to use an architecture like this. You probably want to upscale and downscale workers based on the length of the queue. That is where you need queues. Where do you need pub/subs or publisher subscribers? Even before that, what are pub/subs? What is a publisher subscriber? The name is sort of self-explanatory. Let's look back at our example. User submits some code, sends it to the primary backend, sends it to the queue, gets picked up. Once it is picked up, the worker needs to tell the browser, right? Okay, you have accepted, you have rejected. It needs to send the final result to the browser. If you remember from yesterday, how does lead code do this? Lead code uses polling. If I right click over here and click on network and click on submit, you will see after the submit request goes through, it starts to send a /check request again and again and again and again. It starts to poll the backend. Is it done? Is the submission done? And once initially it gets pending, and then eventually it gets it failed for this specific error. So lead code uses polling. But can you do something better? Can you use Websockets, the thing that we had learned yesterday? Harkirat, what is the benefit of using Websockets here? If you use Websockets, the browser won't constantly poll the backend. Okay, bro, hua kya? Is it happened? Has it happened? Has it happened? It won't overwhelm your primary backend, which will in turn overwhelm your database, because at every step here we're writing to a database as well. I have not kept it in the diagram for ease of understanding it, but whenever you make a submission, an entry goes into the database that says this problem is processing. Whenever the worker is done with it, the worker updates the entry, okay, this problem has been accepted or rejected. So there is a database here. We are not looking at it. But when the user is long polling, then they're overwhelming the backend again and again. Okay, bhai, please give me result, asking it 10 times. What if the server could push? Okay, bro, I am done. Your submission was a TLE, a time limit exceeded, and tells the browser so the browser can show it on the front end. For this, for pushing events from a server to a client, what can you use? Something we discussed yesterday, Websockets. So what can happen after the worker is done? After the worker is done processing your code, getting the response, checking if it is correct, it can send the response to a WebSocket server, which is connected to the browser. Whenever I go to leadcode.com, what if there is a persistent connection to a WebSocket server? And if I'm on this page, what if there is along with the HTTP request that I'm sending when I click on this, there is a persistent connection to a WebSocket server. Anytime I click on run and the worker finally processes it, the worker can signal to the WebSocket layer, okay, yaar, please tell user with ID 1 if he's connected to you. If the user with ID 1 is connected to you, tell them okay, the status of their recent submission was time limit exceeded. That is how a worker can talk to a WebSocket server and publish an event to the browser. Harkirat, why did you not use WebSocket layer here? Why did you not use messaging queues here? Why did this guy not directly talk to this guy? Why can't worker directly talk to the browser? Why are you complicating it with so many services? Good question. A lot of questions. Let's answer one by one. Worker can never directly connect to a browser. Workers are very transitory. They come up, go down. They should never be exposed over the internet. The worker's job is, कि bro, give me a code, I will run it, and I will put the entry in the database. Zyada se zyada, I will publish to a pub sub. That is all. I will not do anything more. So the worker's job isn't to connect to a user. Workers anyways go up and down very quickly. So you don't want your end user to connect to a worker. So you have a fresh service. What do I mean when I say service? Another Node.js application that the browser connects to. Your browser is connected to this WebSocket layer. And whenever the worker completes the submission, it can tell a pub sub, okay, yaar Hakiyat, whoever has user ID 1, please send them this specific status for their submission. Why do you need a pub sub, Harkirat? Why can't this worker directly talk to the WebSocket layer? Great question. This is a beautiful question. Okay, yaar, why do you need a pub sub? Why can't worker directly tell the WebSocket layer? Okay, why tell the browser, okay, his problem is done. This guy can talk to this guy via HTTP. Why does it need to go via a pub sub? And the answer is something we discussed towards the end of yesterday's class. Okay, in the real world, you have a fleet of WebSocket servers. You don't have one WebSocket server. One WebSocket server can only support 10,000 users. You have multiple WebSocket servers. And your user could be connected to anyone. They could be connected to, let's say, a persistent connection to WS3. So whenever the worker is done, it doesn't know, okay, should I send this information to this guy or this guy or this guy? So what it can do is, it can publish an event to a pub sub, and then whenever a user connects to a WebSocket layer, I repeat, whenever there is a WebSocket connection between a user with ID 1, let's say, and a WebSocket server, it can subscribe to an event called maybe, user ID 1, something like that. This guy can subscribe to an event called user ID 1, and the worker can publish. If the worker knows that this submission was for user ID 1, it can publish to the pub sub, okay, user ID 1 has this submission. That way, this worker can directly reach the WebSocket layer versus trying to figure out, ki, achha, are you the person who's connected to user 1? Achha, you are not. Are you the person? So on and so forth. This guy's like, I will publish to pub sub. Whoever wants it, please subscribe from here. It might happen that you have, two browser tabs open, or, you have a mobile app open, and the mobile app is connected to WebSocket 1 server. You share a lot of lead code accounts. You might have a friend who's in Maharashtra. You might be in Chandigarh. You are both sharing lead code accounts. He submits. You should still receive the notification. Ki haan, your recent submission was successful or failure, let's say. So multiple WebSocket servers can subscribe to the same event. And then this single event goes to person in Maharashtra as well, person in Chandigarh as well. Harkirat, why do both of them need? Only one person will be here. Assume there is a use case that whenever you make a submission, a notification comes here that says, Harkirat, you have a successful submission, irrespective of if you have this page open or not. So if your friend in Maharashtra is on lead code and you make a submission here and it is successful, they should also see a notification here. As long as it is the same account, you guys are sharing an account, they should also see a notification here that says, okay, Harkirat, something has happened. Now I will take a pause because I feel I'm connected to a VPN, which I shouldn't be. But let me just take you through the final thing, the final architecture one more time, and then I'll take a pause. But this is the brief of a publisher subscriber system where, in this case, a worker publishes to a pub/sub and whoever wants can subscribe to the pub/sub. If we had a single WebSocket layer, then the worker could directly talk to the WebSocket server. But since we might have a fleet of them, you probably want to go through a pub/sub. Cool. This is what the final architecture looks like. There is a browser over here that sends the request, reaches the primary backend, goes to a messaging queue. Whenever the worker has the time, it is doing its thing. Let's say there are only two workers. He'll first pick this one, then this guy will just pick this one, then will pick this one. They'll sequentially pick up all of them. Whenever they pick a problem and they find the final solution, whether it's an AC or a TLE, they tell a pub/sub that user ID 1 has done something. Whichever WebSocket layer user ID 1 is connected to receives this via the pub/sub and sends it back to the browser. That is a brief of the architecture for today. That is where you need messaging queues and pub/subs. Now let's do a poll. Did we understand this to begin with? Yes or no? Only 77% understood, which is fine. We will do recap very soon. Second question is my internet good? Yes or no? It's good. All right. So let me look at Q&A really quickly. Let me spend maybe 6 more minutes on the architecture before we proceed to coding. After this, it's just a bunch of coding, understanding Redis, understanding how you can create a pub/sub queue. Any specific question? Could you repeat the architecture? Let me try to repeat the architecture of something like lead code. Let me recap it. Let's build the ugliest version of lead code, the one that you might have seen on some other YouTuber's website that was hacked by someone, I don't know whom, not me. The ugliest version is, this is my EC2 machine. This is running a Node.js process. And some user comes and sends a request. Okay, I want to submit a C++ code that looks something like this for user ID, whatever. I'm user ID 1. The ugly version says, okay, our Node.js process will spawn another C++ process and run the code. What is the problem here? Why is this approach ugly? This approach is ugly because the C++ code could look like this. While 1, do something. Then your server is choked. You are letting a malicious user choke your server. What else can the user be writing in C++? They could write something like this, system of ls. The user came to your website, selected C++ as the platform, and wrote the code that looks something like this, system ls. They can explore your file system. What does this do? It runs the command ls on that machine which is running. And if you're running it natively on your EC2 machine, then this C++ process that you're starting, the final output will get returned to the user in the browser, and they will be able to explore your .env files, your MongoDB URL, your Postgres URL, so on and so forth. This is exactly what happened with one of the websites I was exploring. I was like, I can find a MongoDB URL here. So what is the learning? This is the ugly approach. Harkirat, what is the better approach? The better approach is, this machine doesn't run anything. This is your primary backend. You don't want to run any external code here. You want it to run on a different EC2 machine. But the problem is, how do you know how many EC2 machines you need to have? Should you have one EC2 machine? Yes, Harkirat, 1 is good enough. What if 20 people submit at the same time? How will a single EC2 machine handle 20 submissions? It cannot, which is why what you can do is you can maintain a queue. I am Garib. I have just started lead code. I am self-funded. I am bootstrapped. I don't have funding. I only have a single EC2 machine. If more than 20 people or 20 people come to my website and submit, they will slowly see the response. If 20 people click submit, first person will immediately get it. Second person will get it in a while. 20th person will get it very late because they are one by one getting picked by my worker. And this worker is on a separate machine. If the user's code looks like this, it's fine. It's running on an empty machine. This machine doesn't have any code. If the user code has a while 1, then we can, this machine gets choked for 1 second. We can always, of course, have a timeout. If the code of the user takes more than 1 second, then you TLE it and you say, problem solution was TLE dot time limit exceeded. So one by one it gets picked up. That is why you need messaging queues to make sure if 20 people come, your expensive operation can still be handled by a single machine. Of course, if this queue becomes really long, then you should ideally scale up the number of workers that you have that are running the end user code. That is the first part of messaging queues. What is the second part? Second part is once this guy is done solving a problem or, solving the end user's code, which let's say looks something like this, it reached this worker. It was able to solve it. It needs to tell back the user, okay, you have a TLE, your code looked like while one, you have a time limit exceeded. How can this EC2 server talk to this user? There is no easy way. Either to this EC2 server puts an entry in your database. Okay, the submission ID 1 status is TLE. Either we do this. Okay, whenever the response is done, EC2 will set this in a database and the user is polling. Okay, is my submission done? Is my submission done? And then this Node.js process is hitting the database and getting back your status. This is called polling. This is what LeetCode actually does. LeetCode actually does this. We just saw it in action. It was polling the server again and again. This is one approach. This is easy. This does not use pub subs. Why do you need pub subs? Okay, if you are using WebSocket servers, if you have a fleet, what do I mean by fleet? I mean multiple WebSocket servers that you can use to, push events to the client. Your user will randomly connect to a WebSocket server. And when it does, it can tell a pub sub system, a publisher subscriber system, okay, I have user ID 1. If you have any information related to user ID 1, tell it to me so I forward it to him. This guy is very interested in his own feed. If there is any real-time feed, if there is any submission that has been accepted, if there is any, TLE that has come, tell me so I can forward it to him. And then the EC2 worker will of course put this entry in the database as well, but will also tell the pub sub, okay, user ID 1 just got a submission done. It was a time limit exceeded. Please let them know. And then this event can reach WebSocket 2. Another reason for having a pub sub is, what if, there is another feature in LeetCode. If you're on LeetCode, there is another feature. Okay, whoever is live on LeetCode, there will randomly be a bounty here. If you do more LeetCode, if you are active on LeetCode all day, you will randomly one day see claim $5 or claim premium and you can click on it. Let's say LeetCode introduces this. Okay, if you are very active on LeetCode, randomly throughout the day, we will have a lottery and it will come for whoever is currently active on LeetCode. If they want to add a feature like this, all they have to do is again publish to this pub sub. Okay, bhai, irrespective of user ID, like user ID any user ID, please send the lottery button so that whoever is currently connected, whoever is currently on this website will have a persistent connection to the WebSocket layer, be it this one or this one, doesn't matter. And you can say, bhai, WebSocket 3 and WebSocket 2 and WebSocket 1 will all subscribe to the event user any. If there is an event that comes for user any, it will reach all of them. And then, they can forward it to everyone. This might have gone, above your head, which is fine. If you did not understand the lottery use case, it is fine. I just wanted to show you how you can have multiple publishers also and multiple subscribers also. But right now, let's keep it simple. Let's forget the lottery use case. The simple use case is the worker tells the pub sub, this person has a TLE. And if the person is currently active on the website, then the specific WebSocket layer is subscribed to that pub sub. If there is no user with that ID, then this guy will publish to the pub sub. No one will pick it up because this user isn't even active. If this user isn't active on the website, you don't have to send them the event. Whenever they come back, they will refetch their submission directly from the database. That is how you do message queues and pub subs in LeetCode. But the thing to understand is architectures. The first set of architecture remains the same. If you're building a YouTube transcoding website as well, or so YouTube transcoding system as well, the second part of the architecture remains constant. If you ever want to have a pub sub like implementation. There are use cases of it. Chat is, if you remember from yesterday, I told you if you want to ever scale chat, then also pub sub is a decent way to do it, but you can go to yesterday's video and look at that. Now let me do another poll and see if this revision makes it a little bit clearer, because if you understand the architecture, writing the code is, not too difficult. It's actually fairly straightforward. %, good, not great, but I think I should proceed now. And for the people who do not understand, try to understand pub subs and implementations of pub subs and queues. You can worry about this architecture later on. Let's learn Redis. This slide has nothing to do with the last slide. So if you did not understand the last slide or specifically the architecture, it is fine. Let's understand Redis. What is Redis? You might have heard this as, a very big buzzword. Redis is an open source in-memory data structure store used as a database, as a cache, and as a message broker. Harkirat, used as a database. Is it SQL database? Is it no SQL database? Why have we never used this? Why did you never introduce Redis as a database to us? Why did we only worry about MongoDB and Postgres? The answer is, even though Redis lets you store data, you should never use it as your primary database. Harkirat, why? Why should I not use Redis as my primary database? There is a video at the end of slide, some slide here, whenever it comes, that explains this in very good detail. It's a 20-minute video. There you go. It's called, I've been using Redis wrong this whole time. It will show you if you really want to use Redis as your primary data store, you can, but it will make your life very complicated. Harkirat, if you cannot use it as a database, why did they even introduce Redis? Then you don't need Redis. What is the use case of it? The use case is Redis is used aggressively for caching data. Harkirat, what does caching data mean? Caching data means if you have a website, and let's say this is the browser. Let's take an example of a website. Let's say take the website daily code, the website that we are on, projects.next.js.com. It has, let's say, 20 tracks like these. Whenever you come to the landing page, assume this is a simple React plus Node.js application. Nothing too complicated. React plus Node.js plus Postgres. Whenever your browser sends a request to, let's say, the backend, okay, bhai, get request to get all the tracks, the Node.js backend then forwards this request to a database, your Postgres database, gets back the response, and then returns it back to the user. What if 100 people come to your website together? Then you are sending 100 database calls. What if 1,000 people come together? Then you are sending 1,000 database calls. How often do you think this page changes? This track only gets added on one on Saturday, one on Sunday, and now one on Tuesday, one on Thursday for DSA classes. That is it. If this never changes too often, do you really need to hit the database? Harkirat, yes, I know the answer. Static site generation. No, static site generation is for Next.js. This is simple Node.js backend. Here the answer is caching. You want to cache the data. Harkirat, what does caching mean? It could mean many things. You could yahan pe in memory have a variable called tracks, and then only the first time the user asks on this endpoint, should you hit the database? And then you should just cache it in memory. Harkirat, what does in memory mean? It means, put it in as a variable in your Node.js process. Okay, I got the values from Postgres. However, you would get it like prisma.tracks.get or find first, whatever your request was, const tracks equal to this. Then just do a, globals.tracks equal to tracks, or, cache this request in memory. In memory means in the Node.js memory. You can do that. And then all future requests for the next 10 minutes, let's say, you can serve directly from here, from your Node.js backend. You don't have to hit the Postgres database anymore. You can cache them for 10 minutes, let's say. That is one thing you can do. Or you can cache them in Redis. Harkirat, why would I cache them in Redis? I will just cache them in memory. There are a few reasons. Firstly, what even is Redis, Harkirat? Like, what do you mean cache it in Redis? As I said, Redis also lets you store data, right? So why not first time send the request here, get back the response, and cache it to Redis, and then in all subsequent requests, just get it from Redis. Harkirat, if 100 people come, I'm still hitting Redis 100 times then what's the benefit? I will hit Postgres, I will hit Redis. Redis is a in-memory, provides in-memory storage. Harkirat, in-memory storage, it is running a process very similar to a Node.js process here, where your data is stored in memory. So it's very fast retrieval compared to your primary store, or Postgres or MongoDB. That is why usually, very often, you will see Redis as a caching layer. Rather than caching in memory, you should cache on Redis. Another benefit of caching it on Redis is, in a real application, you'll have more than one server because you'll have a lot of traffic. So you'll have a bunch of servers. You can do distributed caching. Akira, what does distributed caching means? It means if one backend server got the data from Postgres and put it in Redis, and now if another browser comes to the second person can also just check from Redis, or the second server can also just check from Redis and respond back. Versus if I had it in memory, then this guy's memory would have it, but this guy's memory would not have it. You would not be able to do distributed caching. But now you can do distributed caching because you have a separate Redis instance running, which has, in-memory data storage where you're caching your data. So that is the most popular use case of Redis. I don't know. I mean, this is debatable, but like the most popularly I've seen Redis being used in big companies or small is to cache data that comes from the database to minimize the number of requests that are going to the database. This is a decent example of, how Redis runs on your machine. As I said, it's a in-memory data store. You should ask a very good question at this point. Kirat, you are saying it is in-memory data store. If this is running on an EC2 machine, this Redis server or Redis process is running on an EC2 machine, you are saying it's in memory, which means it's similar to a Node.js process running here. What if the process dies? What if Redis dies? The data was in memory, then the data got lost because you said it's storing it in memory. The same thing would happen here. If you did not have Redis, forget Redis and forget multiple servers. If you have even a single server and you cache the data here in a variable called tracks, if your backend goes down, then this variable is lost. No, when you restart the process, you will have to hit the database and at least get it once. So in-memory data to gets lost. In-memory means it's in the process that is running. It is stored over there. It is not stored on a disk. So Harkirat, what if Redis goes down? Then all your data is lost. Firstly, if that happens, let's say if the data is lost, doesn't matter. It was cache data. It's not your primary store. Your primary store is still this. If this goes down and assume that the data also got lost, it's fine. It'll come back up as a fresh instance. We will recache the data over here. We are good to go. You had to hit the database a little bit more, but that is fine. So in case Redis did not, back up the data somehow to the file system, your life would have been sad. But Redis does back the data up into the file system. It still stores data in memory. If you ask for it, it'll immediately respond back with the data. It doesn't need to hit the file system to get the data. It has it in memory. You ask it for data, it'll return you the data immediately. But in case it goes down, it can recover back its state by doing two things. Two jargon to introduce, and very commonly used jargon in systems like these, where you need something to be in memory, but you also need to be able to recover it. I repeat, you need something in memory, but in case it goes down, you can recreate the state again. How can you do this? Let me give another example of this. Whenever you go to backpack.exchange and place an order, let's say you click on buy or you click on sell, or anyone clicks on buy or sell, this request goes to a queue. This request goes to a queue, and from this queue, it gets picked up and it's stored in a in-memory order book. Harkiyat, what is an order book? Order book is this thing you see over here. Whenever you place a limit order, Harkiyat, what is a limit order? Forget about it. Whenever some traders place some orders, for example, someone has placed an order, okay, I will buy 1 USDT or sell 1 USDT for 1.00003. And someone has placed an order, I will sell one for 0.0004. Traders place these orders. All of these orders are also in memory in a Rust process. They are not stored in a database. They are in memory, which means, literally a variable called order book equal to this thing, because this needs to be very fast. The order placement needs to be very fast. So here also, what if the Rust process goes down? Then your order book was in memory. All the data got lost. So here also, a similar architecture is used to Redis to make sure that if the in-memory thing goes down, you can still recover the state, the exact order book before it went down. Even though you're storing it in memory, if it goes down, you can recover it back. How can you do it? There are two ways. Way number one is, you maintain a queue of every event. Someone placed a trade on, an order to buy for this much and sell for this much. Since the beginning, all the orders that have been placed, you maintain them in a queue. And if it ever goes down, you just replay all of these events. Someone came and placed one order, removed one order, so on and so forth. You can replay all events and store them in a queue. Redis also lets you do the same thing. Redis lets you store data in two ways. Either a append only file, which means it will keep appending. You added this data, you removed this data in a very long file. And then whenever the Redis process goes down, if you have to bring it back up, you will take that file and, run all the events from top to bottom and be able to recover the state. That is one. You literally have a record of all the events since the beginning. If your exchange has been up for 1 year, you have the record of every order that was placed. You can replay that queue of messages and recover your in-memory order book. Can you guess the problem in this approach? The queue will become very long. What if this has been going out for a year? Whenever the order book goes down, it will take 20 minutes for the order book to come back up because it will replay all the billion events that have been here. How can you do something better? How can you make sure that thoda fast, if I was able to recover my order book, it would have been nice? And the answer is by doing something called snapshotting. You can snapshot the current order book every 1 hour. Hour number 1 of our exchange being up, our website being up, first hour, the state looked like this array. And then, on 22nd Feb, 2 p.m., it looked like this. So you have snapshots every hour and you have the whole queue. You can take the latest snapshot plus all the events that came after and recover the order book. That is another way you can recover an in-memory variable. And Redis does the same thing. You can do a Redis database file. The RDB database file performs point-in-time snapshots. You can tell the Redis configuration, save 901, save the dataset every 900 seconds if at least one key has changed. What does one key has changed mean? It means some single thing changed in the queue. Someone, put some data in Redis or removed some data. If at least one key changed in the last 900 seconds, take a snapshot. So you have, snapshots of Redis at every point, and you can recover the data from here. If you don't understand this, it's mostly fine. That might be asked in an interview, but it's good to know if you want to ever build something like this. If you ever want to build an in-memory data structure, why would you want to build an in-memory data structure? What do I mean by in-memory data structure? I mean, something that's stored in a variable in a Node.js process or in a Rust process. You want to do it because you want this system to be really fast. That is why you might want to do it. And what is the downside of this? If the backend goes down, if the Node.js process ever dies, your in-memory variable dies with it. So you need a way to recover. And how can you recover? Either you have a list of all the events since the beginning, or you have snapshots every 1 hour, plus the events in the last 1 hour, let's say, or last 2 days. So you can recover using the latest snapshot, plus all the events that came after, and you can reach back your order book state in memory. Do we understand how Redis persists data and how an in-memory data structure can be persisted even if it is not Redis? Architectures are very similar. In fact, a lot of this was backpack architecture was inspired from Redis. Mm. 80%. Even if you don't understand this, as I said, it's fine. No one really needs to know the internals of Redis. I'm happy to take doubts at the end. In fact, happy to. Oh, it's 7:48. So let's take a break only. Wow, we've not done any implementation in the first 48 minutes. This is feels like a system design cohort now. Okay, so let's take a 12-minute break. I'll answer some questions, and until then, please run this locally. Make sure this works for you, because iske baad we'll start coding, and you need Docker. So you have 12 minutes. Install Docker. Let me look at the thing. What if the queue dies before a snapshot was taken? Do you mean the queue is unstable and if data gets missed in the queue, yeah, you're screwed. Your data is you missed data. But generally, for example, in Backpack, first the thing reaches the queue and then the Rust process picks events from this queue. So it can never happen that something reached the Rust process and did not reach the queue. Everything first reaches the queue, and then the Rust process picks it up from there. Why don't you keep it in a hash map rather than using Redis? I've seen you're doing caching in CMS via hash maps. Yeah, you can do that. As I said, you cannot do distributed caching then. If I have 2 backend servers, then you can't store it here. That is one of many reasons you might want to use Redis. What if you have a very big variable? Then if you're storing that very big variable in memory, your EC2 might run out of memory. Those might be the reasons you might not want to do in-memory hash maps. But it works. You can still do that. Once a snapshot is taken, do we clear depends on you. You can clear the queue if you want. Redis, from what I know, does not clear it. Redis maintains the append only log forever. From what I know, if you enable append only log in Redis, it will maintain the log forever. Could be wrong, but I think so. Same happens for Postgres also. Postgres also has a concept of a write ahead file, WAF. Pretty much the same thing. Every event before it reaches the actual Postgres database, assume this is a Postgres database, it gets written to a file. What if the value in the database changes? Will Redis cache change? No, that is the question. Exactly, great point. Someone said, Kirat, you are caching data for 10 minutes. What if the database value changes? Then people will see stale data for 10 minutes. So usually what happens is, whenever there is a write, whenever let's say an admin comes and sends a request, add track, whenever there is a write event, you clear Redis as well. You send a request to Redis and you clear the specific thing so that whenever someone asks now, they get fresh data from the database. So another interview question, in case you're interested, now that you've ये topic छेड़ दिया आपने. If there is get requests, you cache them in Redis, Kirat. Just make this cleaner. This was asked to me in an interview very early in my career. Let's say this is your architecture. Browser, there are 2 browsers. There is a user browser that is sending requests to get tracks. There is also an admin browser. I repeat, there is an admin browser that is adding new tracks. Whenever you see a new track being added here, there is some admin that goes to projects.analytics.com/admin/add, clicks a few buttons, clicks on submit, and a new track gets added over here. Now the question is, you made caching. Forget admin exists. If user sends a request, you cache it in Redis. Only one request goes to Postgres for the next 10 minutes. And after 10 minutes, the Redis cache gets cleared and then you re-ask the database. If on the 3rd minute, I repeat, if on the 3rd minute, the admin sends a request to add a new track, what should you do? You have 3 options. Option number 1, clear Redis, put data in Postgres. Option number 2, update data in Redis, update data in Postgres. Option number 3, update data in Postgres, followed by update data in Redis. From first principles, try to answer this. When the admin comes and adds a new track to the backend, you need to make sure that Redis gets the updated data, right? Else everyone will keep getting the stale tracks. The new track that was added, let's say, a DSA 3 tag was added. Users won't see it for the next 10 minutes or the next 7 minutes if this happened on the third minute. So you should do one of these three things. Either just clear Redis so that whenever the user asks for it, they get fresh Postgres data with your DSA 3 tag. It gets put to Redis. You get fresh data. Or you can update the data in Redis. Okay, yaar, a new DSA 3 track was added. Please keep it here. And then you can do the same in Postgres. Or vice versa. You can first send it to Postgres, then send it to Redis. What would you do? Option 1 or option 2 or option 3? Think from first principles. There is just a single answer for this. I will do a poll very soon, but the answer should be very obvious. What would you do? Launch. Wow. Majority has failed. Most people chose option number 3. Some people, second option is choice number 1. Choice number 1 is the right answer. And then 32% selected choice number 1, 42% selected choice number 3, 24% selected choice number 2. Choice number 2 and 3 are wrong. Why? Because it might happen, okay, this request succeeded, update data in Redis succeeded, and your backend server went down. Or in this case, it might happen, update data in Postgres succeeded, and your backend server went down. You cannot guarantee that both will happen. Your backend server is very unpredictable. What if Redis is not responding this time? What if, the server went down is the best example. You updated data in Redis. You told the user, admin, that data update has been done, but you forgot to update the data in Postgres, or Postgres update failed for whatever reason. Then you have stale data in Redis, which will get cleared after 7 minutes or 10 minutes. And then, backend Postgres the data never reached. Same for this guy. One of them might happen, one might not happen, which is why the cleanest is clear the data in Redis. If the Redis data cleared, then store the data here. If clear Redis request fails, then don't do this. Just tell the admin, sorry, request has failed. But the first thing you should try is clearing Redis. After this succeeds, you should try putting data in Postgres. If this also succeeds, then you can tell the user, Harkirat, what if first succeeds but second doesn't? That is fine. If the first succeeds, clear Redis succeeded, put data in Postgres failed, you tell the end user, sorry, your update failed. Of course, you cleared a cache key, but that is fine. It will get refreshed in the next database call from the user. The problem comes when you're able to update one, but the second one fails. Then you will have to revert this. Here I updated in Redis. Okay, DSA 3 was added. And whoever is sending GET requests is able to get the data from Redis. But I forgot to, this request failed to update it in Postgres. I will have to revert this Redis request. We'll have inconsistent data. And same logic applies here. That is why, I'm hoping this is straightforward. Doesn't starting a new EC2 machine takes time? Do we use AWS Lambda to mitigate this or something else in infrastructure? So it does take time. There are a few options here. Number one, you don't usually use EC2 machines. You don't bring EC2 machines. You have a Kubernetes cluster where you bring up more pods. And bringing up pods or Docker containers is much faster than bringing up this thing. You have compute. You have 100 machines running. And as people come to your website and submit, you start small Docker containers. When we finish this lead code, we'll be doing this when we reach the Kubernetes part. If you're interested to learn about this right now, you can go to YouTube and search for my Replit video where I discuss this. But short answer is you don't start EC2 machines. You have a cluster. This is an auto scaling cluster, which will have, 50 to 100 machines based on current load on Kubernetes. And you can go from here. How often would data be cached in Redis? Is there a possibility of data could be stale? If yes, why not use materialized use, which is either updated via a cron job or whenever the underlying table is updated? Why introduce a new cog in the infrastructure, which is also expensive? What do you mean by expensive? Firstly, materialized views sounds super expensive in this case. You're saying create a materialized view anytime data is updated. Data is updated very often. If your, let's say this is your table and, a row changed over here, you are saying recreate the materialized view. Versus if this is your Redis cache and a data changed, you are just changing a single key over here in the data changed, you're changing a single key over here. Versus here you'll have to recreate the table. And what was your other thing? Cog in the infrastructure. And you can also say, why do you need any of this? Just do it in memory. Why do you even need materialized views? If this is your Node.js process, do it in memory. In fact, that is exactly what we do on app.100xapps.com. This tracks that you see, these contents that you see, you don't see it right now, but you get the idea, are cached in memory. So yeah, you don't need it. I'm saying it's the most popularly chosen thing. Okay, you cache in Redis. Why is it popularly chosen? God knows. I joined company 1, they were doing it. I joined company 2, they were also doing it. So I realized this is just a pattern that happens. How expensive is Redis? You can start, I think, I could be wrong on this, let me Google this, but I think Redis runs on single core, which means you can run it on it runs itself is single threaded, which means you can run it on a very cheap machine, and it scales very well to like 1 million requests per second. Okay, 2 more minutes. When you say workers, are these Linux machines? These are Linux machines. Why say they are Docker containers? Like eventually when we reach Kubernetes, if you're really building lead code, you probably want them to be Docker containers, but they can also be EC2 machines. Yeah, they're VMs. Redis is no longer open source free. Yeah, there's some controversy that's happening. I haven't looked at it, but yeah, something is happening there. Make a PR SSG so how to get assigned the issue? Just contribute. Create a PR, dude. This is one project you don't spam with readmes, but try it out. I will close it worst case. Don't feel bad. How 2 different backends access same Redis if it's in memory of a different machine? Good question. This is EC2 machine 1, which is running backend 1, and then EC2 machine 2, which is also running the same backend. You have auto scaled backends basically. And then this is EC2 machine 3, where in memory Redis is running. Here in memory Redis is running. It's not running in memory on this machine or this machine. It's running in memory on this machine. So that is why these guys can access it. Okay, 1 more minute. So you're using this architecture only while building lead code on YouTube. We were never able to reach building lead code architecture on YouTube. We are now building it here on projects on 100xapps.com. This is the architecture that will be followed. Where is Q stored? Again, on a EC2 machine. Everything is on, a VM. Q is nothing but, in the end, it's all Redis running, which lets you do queues. Or if you're using, something else, you're using RabbitMQ. It's just a process running on a machine that is maintaining a queue for you. It's all running on an EC2 machine. Usually it will be on a separate EC2 machine. If this is your backend EC2 machine, you will have RabbitMQ running on a different machine. Size of queue matters in what? What does in-memory data mean? How does Postgres save data? In-memory data means the process that is running. If you are running a Node.js process, if there's a variable A over here, that variable is in memory. It means it's currently in RAM. If you remember the architecture, it's sort of in CPU right now. Not CPU, it's in RAM. It's in random access memory, which is, very frequently and easily accessed, very expensive. You only have 8 GB RAM. You have 1 TB SSD. Why? Because this is very cheap, but this is very hard to access. If you store data here, it takes time to fetch that data. If data is stored in RAM, you get it immediately. What is the downside? Downside is, your other question was, where does Postgres store data? It stores data in disk. Yeah. Unless I'm very mistaken, it does store data in disk. And whenever a request comes, it'll get that data not from RAM, but it'll get it from, your SSD, somewhere in that folder. If you remember, how did we start MongoDB? We said Docker run. I don't have it right now, but if you remember, we ran Docker run, we had a volume, /data/db mounts to something. This /data/db is where Mongo dumps all of its data. So it's stored on the file system. What's this? Redis is stored in memory. Okay, I think we're at 8:02 now, so I should start. Snapshotting thing again, how data is persisted in just Google read, but high level is forget append only file. Let's keep it very simple. You just take a snapshot of the database every few minutes. You dump the database every 900 seconds, or let's say 60 seconds, or every 300 seconds. Okay, by dump data, backup data. If there is something happens in this 60 seconds, then you're screwed. That data gets lost. If you don't have append only log, then you can just have a snapshot every few seconds, every 60 seconds, every 30 seconds. And if there is some data that gets, if it sort of broke between 2 60-second intervals, then this much data will be lost. But that is fine. It's not a lot of data. You still have a snapshot from very recent snapshot. But if you want, literally no data gets missed, then you need a append only file log. You need a log of every event that happened. Cool. All right. Let's do a poll again. I think I've answered a few questions. Hopefully things feel better now. But either way, I think we will proceed and write some code next because it's 8 already. And code writing is fairly straightforward. All right. 92% is great. Let's move on to writing some code now. First thing you have to do is start Redis. This is similar to starting Postgres. This is similar to starting MongoDB on your machine. You can either go to Redis, documentation and install Redis on macOS. You can totally do this. You can do a brew install Redis, same for Windows or whatever. Or we have learned this many times now. You can run Redis using Docker. This is usually the standard port on which Redis runs, which is why the port mapping is from 6379 to 6379. Run it in detached mode. You don't have to give it a name. Feel free to give it a name. But what are we running? We are running Redis. Let's copy this. Let's open a terminal. Let me kill everything I have currently. And let me rerun Docker by running this command. Now it will work for some of you, might not for some of you, depending on your Docker configuration. It might take a long time for some of you because you might be fetching the Redis image. So either way, try to run this. And for me, I will have to change the name because there is one that already exists with this name. Docker run -- name. Give it a random name. You don't have to give it a name. You can remove this completely. In detached mode, which means run it in the background with this port mapping. What are we running? We're running the Redis image. If I do a Docker PS now, it tells me, Harkirat, on your machine, port 6739 is serving Redis to the port 6379 on the Docker container. This is starting Redis. What does Redis let you do if you remember from the beginning? Redis is an open source in-memory data structure store used as a database, cache, and message broker. We understood it is used as a cache. Chalo, it can be used as a database. I shared there is a video that you can go through if you want to understand how you can use it as a primary database as well. But message broker is interesting. What does message broker mean? It means the two things we discussed initially. Messaging queues as well as pub subs. Redis lets you run both of them. That is what we'll focus on today. We'll understand how you can use it as a database or cache as well, but we'll focus on messaging queues. After you run this command, you have to run one more command. See, we have started Redis. If you run the first command, which is docker run, Redis with this port mapping in detached mode. After you run this command on your machine, if this is your, Mac machine, then you have Redis running in such a way. Here, any request that's come to 63, whatever the right port is, this might be the wrong port, is being forwarded to a Docker container that is running Redis. On, the port here is also 6739. You get the idea. The problem is, how do I talk to this? Let's say I started very similarly. I started Postgres. If I started Postgres on my machine, very similar using Docker, how would I talk to it? How would I send an insert request there? How would I send a delete request there? I would create a Node.js process. I would use the PG library, or I would use Prisma. And I would give, this Postgres URL to it. And it would be able to send a create, a delete, an update, so on and so forth. This is how I would do it if I was using Postgres. Do you remember PSQL? I shared, you can use the PSQL CLI, command line interface, to also send an insert query ke bhai, insert into users something, or delete from users, so on and so forth. PSQL was if you remember, command line interface. Harkiyat, what is a command line interface? Something you can run here in your terminal. If I run PSQL here, it gives me something. Connection is not correct because I haven't given it the right username, password to my Postgres database. I don't even have a Postgres database running, but it is nice to have a CLI that talks to Postgres. So I can directly run commands in the terminal. I don't have to start a Node.js process. We will of course eventually start a Node.js process. But before we get there, let's try to interact with Redis via CLI, via a command line interface. Harkirat, so you are telling me I need to install something on my machine now. You will tell me to install some Redis -CLI, very similar to PSQL. Yes, ideally you would have had to install this, but thankfully, whenever you start Redis in a container, this already has Redis CLI inside. This already has Redis CLI inside. You can just go inside the container and run Redis-CLI and talk to Redis. You don't have to install it on your Mac machine. Can you install it on your Mac machine? Yes, you can. You can install the Redis CLI on your Mac machine, but why should you? It already is in this container. Why not go inside this container and run Redis CLI directly there? Harkirat, how can I do that? If you remember, you can go inside a container by running the docker exec -it, which means interactively, container ID /bin/bash. If you run this command, you'll be able to go inside your container. I have a container running. I want to go inside. What does going inside mean? It means I want to run bash commands. Nothing else. It doesn't mean I'm not going inside the Docker container. I'm just running bash commands on that Docker container. How can I do it? Docker, first run docker ps to get the ID of your container. Then run docker exec -it, which means interactively the container ID /bin/bash. Run this command to go inside the container and then run Redis-CLI inside the container. Once you reach the container, run Redis-CLI. Reach this point and then we will proceed. What have I done? Started the container by using what command, Harkirat? I used this command to start the container. Then I used this command to go inside the container. Then I ran Redis-CLI. It already exists in this container. And I'm seeing something like this. Now I can send it commands. If this was Postgres, I could have written select star from something. This isn't Postgres, so of course SQL won't work over here, something else will. But have you reached this point? Take 2 more minutes. Try to run it locally, then connect to it locally using Redis CLI. If you want to go down the fancy route, you can also, install it directly on your machine. You can download it from source code. You can build it from source code. You can do this basically. If you want to, if this doesn't work for you, you can also download it from here, unzip it, and then you will find Redis server and, or you also have to make it. You need to have C++ on your machine, which is why, this is just easier. You can still follow this. I'm happy to post this if you want to directly install it on your machine, but it's just easier if you use, a Docker container. How many of you are able to run this much locally? How many of you are able to interact with your Redis instance that you just started? Oh, well, most of you are. So great. It was 90, then it reached 84, 85-ish. I think that's decent. Cool. So now the question comes, let's make Redis, do some magic. What did Redis say it can do? It can store data and it can act as a message broker. Let's start by storing data in it. The way to store data in Redis is give it a key, for example, user, and then give it a value. I don't know what is happening here. Value could be, Harkirat. Eesh. Something is happening here. But if I press enter, this is the command that I ran. Set user Harkirat. It's like storing a key value pair. I just stored a key value pair over there. Here the value of user is Harkirat. If you were using or storing using Redis as a cache, I would have stored something like this: set tracks of whatever tracks exist on projects.nextsteps.com. So unfortunately you can only store a string over here. You cannot store an object, but you can always store an object as a string, right? You can always stringify it and store it. So I would have stored something like this. Okay, it is an array, the first one of which is TypeScript. So title TypeScript, comma, description, whatever this description is, so on and so forth. This is how I would use Redis. Of course, this set would happen via a Node.js process. This wouldn't happen in a terminal, but this is how I would cache data if I was using it as a cache. If I was using Redis as a cache, I can set data like this. How can I get data? Can you guess? Get tracks. It gives me, these are the current tracks that you have. And as you can see, it was pretty snappy, happened pretty quickly. I can also delete tracks. And now if I try to get tracks, it says nil, which means nothing got returned. That's a brief of setting data. Probably the simplest thing in Redis. It lets you set, get, and delete data. Very similar to a database. So nothing new over here. Only, this isn't SQL. There are no tables. There is no structure to your data. That if you want to read through, this video is exactly that. This video is what I call over engineering. Okay, just because Redis can be used as a database does not mean you should. I think this video is satirical also from what I remember. I could be wrong. But they say if you really want to use Redis as a database, you can. But you will see how complicated it gets. So feel free to look at this video. One more thing I will quickly introduce, which if you don't understand, it is fine. Sets and gets are good enough. Is hash set and hash get. If you want to store multiple things for a single key, okay, bhai, user :100's name is John Doe, email is this thing, and age is this thing. If you want a more SQL-like structure, okay, user with ID 100 has these things. If you want to associate multiple data or like multiple things with the same key, you can use set, which means hash set. Set on the hash, okay, the user with ID 100 has this name, this email, this age. In the future, if they have an address, this address, so on and so forth. Here you can set just one thing on a key. Okay, for tracks, it makes sense. If we have a very long array of tracks that we cache for projects on 100xsteps.com, so it's fine. It's we don't need set. But if you want to use it as a database, you will need set. If I copy this and paste it, you will see it says integer 3. It says I've set 3 things. I've set the name, email, and age. Now if I do a get user :100 name, it says John Doe. Address, address doesn't exist. Email, so on and so forth. So hashed get basically means create a hash map for this key, create an object for this key. Name is John Doe, email is something, age is something. You can add more things. So set user :100. You can be like address or city, Delhi. Now it has 4 keys. I can do a get user 100 address, so on and so forth. So if you want to store complex data, you use set. If you want to store simple data, which for example, caching could also be in a way that this website is built in a way that the people who have paid see some tracks, the people who have paid for DSA see DSA tracks. So it might be user specific. In that case, then also you don't need set. Then also you can do something like this. Okay, set tracks for the user with ID 100. So you can do set tracks :100 as this, and then whenever user with ID 100 comes, you can do this, get tracks 100. Because it might happen, this website becomes user specific. The tracks become user specific. Who have paid will see something, not paid will see something else, so on and so forth. So that's gets and sets. Not really needed today, but a thing you have to introduce if you are doing Redis. Do we understand gets, sets, We haven't done it using Node.js yet, but do we understand it, using the CLI? We do. Very simple. Then the next organic step is how to do it using Node.js. Oh, fucking A. Very easy to do it using Node.js. Yeah, we'll see it eventually, but let's, not do it using Node.js. Let's do queues using both CLI and Node.js, because if you understand how to do queue via Node.js, you can very easily understand how you can do sets and gets via Node.js as well. So let's understand Redis as a queue. Let's build a system like this. Okay, a browser sends a request to a primary backend. Backend puts it in a queue. Workers pick it from a queue. So we have to write the code to number 1, this code right here, a primary backend in Express. Number 2, we have to write worker code. That's it. We can send the request from Postman. We don't need to write any client-side code, but we have to write 2 Node.js servers. A primary backend that pushes to a Redis queue, a Node.js worker that pulls from the Redis queue and, processes the thing. Redis has a queue. You can also push to a topic or queue on Redis and other processes can pop from it. That is what we want, right? We want one process to push, other processes to pop. Good example of this is lead code submissions that we need processed asynchronously. Let's understand how you can push and pop using CLI. Once we understand this, in the next slide, we will actually build this and, write some Express code and, Node.js code over here. The way to push to a queue in Redis is this. Here, the queue called problems. I'm going to push, let's say 1 over here. Of course, you wouldn't push 1 when the user comes and, gives you all of these things. You will most probably put all of this data in the queue because you want the final worker to know, okay, problem ID 1 ka code, this has been submitted by this user, so on and so forth. So it won't be as simple as this, but just to start, let's understand what L push means. What does L mean over here? Push, I understand. What is L? It means push from the left side. As you push more and more things, they'll get put here on the left side. Harkirat, we should use R push. I want first thing to be pushed here, then second thing to be pushed here. It doesn't matter. The main point is if you're pushing from one side, you need to pop from the other side. If you're pushing from the left, make sure you pop from the right. Yeah, otherwise it will become a stack. So if you do a L push, make sure you're doing a R pop. If you're doing an L push and you do an L pop, you have a stack. You don't have a queue. Because if I push something if this is my queue, and if I'm pushing from the left, first thing I pushed is 1. And then second thing I pushed from the left is 2. And the third thing I pushed from the left is 3. Where should I pop from? Should I do a L pop? No, I should do a R pop. I want 1 to be picked up first, then 2, and then 3. So this always gets confusing. If you want to create a queue, if you're pushing via L, pushing from the left, pop from the right. If you're pushing from the right, pop from the left. And if you want to create a stack, then L push and then L pop. Let's see this in action. Forget the database. Forget setting data. It's a different, that doesn't conflict with this. This is queues. Push to problems 1. 1 is a very weird, payload to put over here. What should we ideally put? Something like this. Like a JSON object that says, problem ID 1, user ID 2, so on and so forth. A bunch of data here. This is what you should ideally push. Even though this looks like an object, it's actually a string. The Node.js process will be able to parse it as JSON later on, but Redis doesn't support JSON. You have to store a string. So we have, a JSON.stringified string. I have pushed twice. How can I pop? Now what will pop in the real world? The worker will pop. But just to try out here, if I do an L pop, L push tha to R pop, problems. What am I missing? Oh, sorry, I exited out of the CLI. R pop, problems. I get 1 first. 1 was the first thing I pushed. 1 is the first thing I popped, very similar to what I showed here in Accelerator. If 1 was the first thing that got pushed, 1 was the first thing that should have gotten popped. What was the second thing I pushed? This thing right here. If I do an R pop problems again, I see the problem IDs over here, which means, and if I do it again, what happens? It says nil. The queue is empty currently. This is how you push and pop. Do we understand push and pop via CLI? If we do, then we can move on to the Node.js code. There's one more thing called BL pop. But if you understand this only, then we should move to that. We do understand this. The last thing that's left is blocking pop. A lot of times you want I want to wait for when something comes here. I want to block the thread until something comes to the problems queue. So let me open another terminal here, docker ps, and then docker exec -it/bin/bash. And here, if I do select, what am I doing? Redis-CLI. I have two Redis clients. I will produce from this one. I will subscribe on this one. I will do a BL pop problems. I repeat, not L pop. Blocking L pop. Sorry, has to be R pop. My bad. Blocking R pop problems. And from here, I will do a L push 1, let's say, or problems 1. If I press enter in the left terminal, I also have to give a third argument here. I will share what this third argument is. For now, let's just select 0. You will see it is blocked. It doesn't let me do anything. It is saying, bro, I am blocked until someone pushes on this queue. And if I push on this queue, you will see the blocking went away. So what does BR pop problem 0 do? It says, bro, I am going to be blocked for an infinite time. That was 0. That's what 0 means. Okay, I will be blocked for an infinite time until someone comes and pushes something. Until then, I will just wait. Harkirat, what if I make this 5? It means I'm going to wait for 5 seconds. 1, 2, 3, 4, 5. Nothing happened. It exited. It said, bro, sorry, nothing came. 5 seconds passed. So usually you do 0 over here. We will do 0 in our final process. And whenever something gets pushed, the blocking goes away. You're able to get something here. Cool. That is what BL pop is, or BR pop is. Hoping it's straightforward. And not going to do a poll now. Let's move on to what? Let's move on to implementing this first part of lead code in Node.js. If we implement this, I think we're good for today. I don't think we'll be able to do more. What's left is pub subs. I'll cover in an offline video. We'll cover pub subs and then, the code of Node.js in pubs. Basically the second part over here. What we're covering today in the live class is this code. What we'll cover in the offline video is this code right here, even though a lot of this, this code. A lot of this second WebSocket part was left as an assignment. So I had to either way do it in an offline video. But let's first, talk to Redis via Node.js. Let's do the same interactions we did via CLI via Node.js. Very simple. You use the Redis library. Okay, what is the Redis library? What is the Express library? Lets you create HTTP servers. What is the Axios library? Lets you talk to an HTTP endpoint. What is the PG library? Lets you talk to a Postgres database. So what is the Redis library? Lets you talk to a Redis database. Let's write the code just for this primary backend that pushes onto a queue. Let's not worry about the worker code today. I'll just create an offline video for it soon. Okay? Even though it's right here, so you can feel free to copy it. All right. So ideally you should create 2 folders. Let's just do it. Let's just do both of them. Let's write the primary backend. Let's write the worker code. And let's try to publish here, subscribe, or push to the queue, pop from the queue, and see if it works or not. Create an empty folder, and inside this create 2 another folders. I repeat, single empty Node.js folder inside which you create 2 folders, one called Express server, one called worker. Let me do a poll because this is a very simple code. Do you want me to I already have the code locally. Should I just explain the code? Yes or no? If you select no, then we will write the code together. But should I just explain the code? Yes or no? If you select no, then I will write the code from scratch with you. Yes. I'm in very close competition here. It's almost a 50-50. So we can write it. It was a 50-50. Okay. Create an empty folder inside which you create 2 other empty folders. I will do it fast though. So what did I say? Let me exit out from everywhere. You can exit out from the CLI. You don't need it anymore. We will be now interacting via the Node.js process. Create an empty folder, call it week 19, lead code clone or whatever you want to call it. And here create two folders, call one worker, call one express backend. Open this in Visual Studio Code. You can call them like something else as well. The name doesn't really matter. All right. Going to give you guys maybe 15 seconds. Create two empty folders, nothing too fancy, very simple stuff. Two empty folders that, don't have anything. Open it in Visual Studio Code. 10 more seconds, then I'll proceed. Sorry, one more second. All right. Next up, what do? You initialize empty package.jsons, tsconfig.jsons, done many times, not going to repeat it. I'm going to go to the first folder called express backend and run these two commands, npm init-y, npx tsc-init. I'm going to go to the other folder, run the same two commands, npm init-y, npx tsc-init. If this doesn't work for you, you can copy over tsconfig.json from a random project on 100x devs Cohort to GitHub. You'll find a TypeScript project, just copy over tsconfig from there if npx tsc-init doesn't work for you. What is the next thing we do? We go to tsconfig, we change the root dir to source, src, we change the out dir to dist. Done this many times, hoping it's straightforward. Going to wait for 10 more seconds. What did I do? These were the two commands I ran in both the folders. Now both the folders have package.json and tsconfig.json, and I changed the root dir and out dir here also. What's the next step? Create source/index.ts in both the places. Source index.ts, source index.ts. All the steps are present here as well. Do these two things and then maybe ignore this and this for now. Just create a source/index.ts in both the folders. Going to wait for 20 seconds and then I will proceed. This is what my folder structure looks like right now. Yours should look the same as well. If you want, feel free to, install these dependencies as well. Make sure you're installing the right dependencies in the right folder. Express server, only this one needs Express. This guy does not need Express. So make sure only here you're installing Express. Five more seconds. All right. Now let's install the dependencies. The worker needs a single dependency. What does the worker need to do? It just needs to pull something from Redis and do a fake processing on it. We are not writing the code to actually run the end user's code. That will come once we reach Kubernetes. We're not writing the code to actually run the end user's code. We are just writing the code to pick and then maybe run a fake timer of 1 second, processing code, and then sending back a accepted to the user. So this only needs one dependency, the Redis client. So in the worker, all you have to do is npm install Redis. But the primary backend needs to do two things: expose an HTTP endpoint, which means it needs Express, and also needs to push to a queue, which means it needs Redis. So on the Express backend, npm install Express at types/express and Redis. Cool. Now comes the part to write code. This guy needs to have a single endpoint. You can also copy this code. I'm going to write it from scratch. Import express from express and import create client from Redis. This create client lets you, well, as the name suggests, const client equal to create a Redis client. And then, on this client, you can call client dot, what was it? lpush or lpop. So it's pretty much that easy. You just have to create a client. There's one thing I'm missing. You also have to do a client dot connect over here. Ideally, you should await this as well. You cannot await on, the global thread over here. So if you look at the final code over here, that's a little more cleaner. If you look at the final code over here, we have a start server function inside which we first await client.connect. Make sure the Redis client has actually connected. And then we listen on the express port. So this is the right way to start the express server. First, make sure you are actually connected to Redis. Otherwise, someone might send a request and you might not be connected to Redis itself. So, it'll become a problem. So this is the right way to do it. I'm just going to, wing it right now and, hope the client.connect happens before a request comes from the user on the app.post submit. Let me write the rest of the code. Const app equal to express, app.use express.json, and then app.get or whatever, post /submit const, whatever problem ID, user ID, and code, maybe language, all these things the user will send me equal to rec.body. And what do I have to do? Ideally, I should push this to a database. So I should do, prisma.submission.create. We don't have any Prisma schema yet, which is why I'm not doing it. But ideally, you should store it in a database as well. And what else do we have to do? Client.lpush submissions. Client.lpush to the submissions queue. What does the first argument mean here? The first argument is, I close that. The first argument is, whenever we are doing a push, if you remember from a few seconds ago, whenever we were doing a push, I did a lpush problems, and then I gave it, some object, ID 1, so on and so forth. So this problems, the name of the queue is the first sort of argument. The second argument is all the payload. I've taken all the payload from the user, dumped it over here. That is all that you have to do. Rest.json message submission received. This guy is publishing to the queue. We haven't written any worker code. No one is consuming from the queue, but at least, publishing side is done. How can I confirm if it is working? And for this code, as you can see, is less than 18 lines of code. If you look at this code, it's slightly more because it has, the start server logic to make sure the client connects first. This also looks very fancy the way I've extracted it, but it's pretty much very similar code. The way to make sure it works is I will do a tsc-b to actually compile my TypeScript code into JavaScript. You can also copy this code, paste it here and compile it because both the codes do the same thing. And then node dist/index.js to actually start the express server. How is it starting considering I haven't done a app.listen? App.listen 3000. Yeah, I forgot that. tsc-b. Yes. Now I'm listening on port 3000. Let me try to send a /submit via Postman. You should send, whatever. If you've copied this, then submit is the same, but the arguments are a little different. So make sure you send the right arguments. They're actually pretty similar only. All right. Local 3000 /submit. Yeah, pretty similar-ish arguments. I think user ID is one thing that's missing here. Send, and it says submission received, which means what? Control reached here, which means what? Most probably this has succeeded. This is an asynchronous operation. You should ideally await it. Or, this will probably be have a callback at the end. I'm sure there's a way to, await it. L push type of what is this routing by default. See, do we have something here? Await. You can await it, right? Oh, okay. I was not able to await it because async. There you go. So you ideally should await it. I mean, if you don't await it, then it might happen that nothing reached the queue. You still send the user, this thing. So you should ideally await it. You should ideally put this in a try catch. Only if it succeeded should you send the user this. Else you should send the user submission failed for whatever reason. Failed. So you can make it as fancy as you want, or catch. But yeah, if I restart it, compile, Node.js, go to Postman and send data, it says submission received. Question is it actually pushing something to the submissions queue? How can I check? Okay, anytime the endpoint is being hit by Postman, something is reaching the queue. How can I confirm this? I'll just go to my terminal, do a docker exec. Do a redis-cli, do a rpop submissions, because submissions was the key of my, when I was doing an L push, where was I pushing? To submissions. So where am I popping from? Rpop submissions. And I see problem ID 1, user ID 1, code something, language something. Pop again, I see it again. If I do let me clear the queue. Now let me do a BR pop. Okay, I will remain blocked until something comes over here. BR pop submissions 0. And as you can see, it is blocked, and it will remain blocked until I send a request from Postman. So it is blocked right now. As you can see, this is, not exit out. If I send the request, you will see the submission came over here. So we are able to populate the Redis queue correctly. We have confirmed this. The worker logic is pending, but do we understand this part? Sending data to the Redis queue. I'm assuming it's pretty straightforward actually. Great. So let's write the worker code. Worker code में क्या है? It's as simple as going to worker, doing an npm install of Redis, opening worker/index.ts. And what does this guy need to do? It also needs to create a client from Redis. That is the first thing this guy also needs to do. But after it has created the client and after it has connected, what does it have to do? It needs to infinitely keep hitting, keep doing something again and again and again and again and again until pretty much infinity, until you stop the process. It needs to keep blocking and waiting for other people. What do these workers do? When you start these workers, they are just polling the queue. Do you have something? Do you have something? Do you have something? Achha, you have something, give it to me. I will run it. And then, whatever, do things afterwards, send it to a pub sub. But, they infinitely need to keep polling the queue, which is why you can put a while one here, infinite for loop, doesn't matter. And do, here you probably want to await the client.connect because, the while loop will immediately do a, client.rpop submissions, and you don't want that. I think I can just await this as well. Const response equal to await client.rpop. This, I just need to put it in an async function because I'm doing a bunch of await calls over here, and I can do this here and I can call it main. Now I've done a few things here, nothing too complicated. I just called the main function, which is asynchronous, inside which I first awaited कि भाई client.connect हो जाए. Let me first connect to the Redis client. Once I do, then I'm just getting the response. Then I can, here I will actually run the user's code. We don't have any of that logic yet. We are not writing the logic, even though it's very similar. Very simple. You can do a docker exec over here. If you want to build a janky version of it, just run the user's code in a Docker container. We're not going to do it, but yeah, we'll just do a, await new promise. resolve set timeout. Harkirat, what does this line do? You have introduced a very weird line. It just, awaits for 1 second. How, Harkirat? What does it say? It says await a new promise which will be resolved after 1 second. Harkirat, very complicated syntax. Put it in ChatGPT. It will tell you how it does it. But this is similar to simulating an expensive operation, similar to awaiting for something that's taking more than 1 second, awaiting on it, not blocking on it. Your thread isn't blocked here. Still do other things. There is nothing else in this application. It's just doing this. So, it'll just await. But you get the idea. We're just simulating running the user's code. And then, here we should ideally send it to the pub sub. We'll cover that in the offline video. Then, we can log processed users submission. That should be pretty much it. The final code, if you look at it in the slides, start worker does a client.connect, logs worker connected to Redis, while true, gets it from the submissions queue. Oh, I need to pass in another argument here. The timeout. So submissions, 0, await client.brpop. Yeah, let's do a brpop. Let's wait for, let's keep waiting here until you actually get back a response. If we don't do a brpop, this response will be null from time to time. And, we'll just keep running this loop versus let's just await. Let's just do a blocking brpop. Right, pop, but stay blocked over here until you get something. And then, process submission, which here, just does the same thing. Extracts the data from the, you can probably also, console.log response to actually see the thing that was put in the queue, the thing that was actually put in the queue. Let's log that over here to see what it looks like. Cool. Let's compile the worker code. Let's run it twice. I repeat, I'm going to run the worker maybe more than twice. Let me run it 4 times. Because in the real world, you will have multiple workers because your website could have 100 users. So let me open the terminal. Let me split it into 4 windows and let me go to this worker folder and run 4 workers. cd node dis/index.js. Run the same thing here. Node dis/index.js. I'm starting 4 workers on my machine. And now all 4 of them are waiting. Okay, when will something come in the queue? Let me put something in the queue. How can I do that? I will start the express backend as well. Node dis/index.js. And I will start sending postman requests. So let me put this on the left, the 4 workers. Let me put postman on the right. Let me start sending requests. As you can see, they are getting picked up by random workers as time goes by. And they are processing all the submissions. What if all the workers are down? What if all the workers are down? It is fine. They will keep piling up in a queue. And as you can see, more and more people are sending submissions. It's fine. They are waiting. Your workers are down. But you can always bring back up workers and they'll start processing the code again. So that is the benefit of such a asynchronous system. Okay, if the workers are ever down, you can just bring them back up. They'll start polling from the queue, and then I can keep resending. These guys can keep repicking. That is how you build the first part of what we're building today, which was this architecture right here. What is left to be built? This architecture right here. I will cover in an offline video both what is a pub sub and how a worker can publish to a pub sub to a WebSocket server and pull it from there. All right. I think that will be it, guys. I will do a poll. Did you guys understand everything? And then we will open it up for questions. Great. All right, going to open chat. Feel free to drop off. The class has officially ended. Thank you everyone for joining. And if you have no questions, I'll see you guys maybe next week, because next week might be a holiday. We'll do a poll, and if people want a break before 1-200, we'll do a holiday. Else we'll continue. All right, questions. There you go. Let me, oh my God, so many questions. Stop. Okay. Recap, please. Let me do a quick recap. Won't do very deep recap because, 92-93% understood. I'm assuming that means it's pretty simple. What we learned today was queues, publisher, subscribers, and Redis. Why did we introduce Redis? Because Redis lets you create queues and Redis also lets you create pub subs. Question is, what are queues and what are pub subs? Queues, as the name suggests, is a queue where one Node.js or Golang or Rust process can push something to a queue, and another, again, Node.js, Golang, doesn't matter, any process can pick things from here. This message queue architecture is very popular when you're building a system like lead code. Harkirat, why is it popular in lead code? Because in lead code, you're letting the end users run an expensive operation on your compute. What is compute, Harkirat? Your machines. You're letting the end user run a C++ code on your worker. When you do that, you want to make sure you don't run it on your primary backend. You also want to make sure that I only have limited workers, 3-4 workers. If a lot of people send me data, I can't simply tell the workers, do this. I can only push it to the queue and hope that the workers will auto scale eventually. If the queue is very long, they will become 20 workers and pick up and start to process them. That is why one use case of using message queues. What is the other thing we learned? Pub subs. What if a worker that has processed the user's code, what if they want to send the end user, okay, bhai, there you go, your submission was accepted or rejected. How can they do that? The worker cannot directly connect to the browser. The worker is very protected somewhere. When we run this, I might be, buying 3 machines and running the workers there. Why would I rent a worker on AWS when I know, it needs to run all day and 3 are good enough? So this thing can't directly connect to the browser is the point. These might be running in someone's home. These might not necessarily be running on an AWS machine. So what these guys can do is they can publish to a pub sub, which is running on the internet, running on EC2. Okay, bhai, please tell user ID 1 that something has happened. And the WebSocket server that is connected to user 1, in case the user is on the website. If the user is not on the website, great. But if the user is on the website, or more specifically, if the user is waiting on this page after submitting, what was my response? Was it accepted or rejected? I'm waiting. Then the user has a persistent connection to a WebSocket server. The worker can tell the WebSocket server via a pub sub, user ID 1 ko send this thing. So that is the general architecture that we learned today. We just learned a little bit of implementation of this as well. Can we implement Redis push in Next.js as well? Want to optimize my API project? You can, as long as you are doing it on the server. Just don't do it in a client component. It will not work. But if you're doing in a server component, it'll be fine. Is Redis queue equal to messaging queue? That is a good question. I'm being very cautious. What is a messaging queue versus queue? Yeah, I'm being very cautious of saying the word queue and messaging queue. Message queue versus message broker. I would assume queues and message queues can be used interchangeably. Message queues and message brokers are different things. But I think queues and messaging queues can be used interchangeably. Could I be wrong? Yes. So please Google this. Don't take my word on it. All workers are taking all the items in the queue, right? Only one should take it, right? No, not everyone is not taking only one is taking one item. If you look at the code, if one worker will pop, then BR pop, the other will pop a different one. Let me open the terminal. I have 3 running, right? I have 3 workers running over here. Let me open all 3. Let me restart the 3 workers. I have 3 workers running. Or even better, let's run 2 workers. I have 2 workers running. If I go to Postman and send, only one picked it up. Both of them did not pick it up. If I send again, only one picked it up. Both of them did not pick it up. So the code makes sure only one is picking it up at one time. Does this worker try to pick up the work? Yeah, so it's similar to this. Okay, a few people are feeling it. It's similar to if I open 2 terminals and in both of them I run, BR pop submissions and then BR pop submissions. Then, whichever one got there first will be able to snag the item from the queue, and the other one will still have to wait. So, that's what's happening. They're not both going to get the same item. Topic related questions on Notion. Does okay, answer that. If auto scale the fourth worker, will the third? Okay, a lot of people are asking the same question. The answer is Redis will make sure only one item is able to, or one worker is able to pop. As long as one pops it, the other one will not get the same thing. Abhishek, if I answered that, all work answered that. Can we implement answered that? Okay, same questions again. Worker code repeat. I will go through worker code. One more time. Break please. Bas break hai bhai, chutti ab. Are there limits of Redis cache to store data? There should be. I'm sure there is a limit. Redis hset limits. Redis can handle up to 2 to the power 32 keys and was tested in practice to handle at least 250 million keys per instance. Every hash list can store up to these many elements. So your answer is right there. You should learn to Google, by the way. Most things you ask me, even I don't know the answer. I will Google in front of you. Can we implement this Redis? Okay, answered that. Worker code repeat. I will repeat worker code. Let me answer all the questions and I will do it. Trying to answer questions only related to the class. Why Redis queue? Like, why can't we create queue the way C++ DSA problems? Good question. Question bhai is asking, okay, Harkirat, why have you done this? Very bad. We come from the DSA world. Why are you doing this? This is an EC2 machine where you are running a Node.js process. And this is pushing to a queue in a different EC2 machine, or maybe the same one, doesn't matter. But a different process it is pushing to. Why do you not create a queue like we do in a C++ process? The queue in a C++ process is in memory. It is a variable in your Node.js process where queue equal to empty queue. How will another Node.js process that's running somewhere place else get access to this queue? It cannot. It's in memory over here. I mean, it can technically, but it can't. A different machine though it cannot. That is why you have a second process whose job is to maintain a queue so that this guy can pull things from here. If you put it in memory like you do in C++ when you're doing algorithmic problems, other processes don't have access to it. When you're solving C++ problems, you have a single process. When you're doing a lead code problem, you have a single C++ process, right? You don't need another C++ worker process to get access to this queue. But here we do. So you cannot store it in memory. You store it someplace else, more specifically in, a messaging queue. That hopefully answers your question. Worker code repeat, a lot of people were saying, or one person was saying again and again, I don't know, one of the two. So let me do that. Let me repeat the worker code one more time. As you can see, thankfully, not a lot of lines of code. We create the client. Actually, okay, I get why it might be jarring. Let me see if I can make it slightly better. I cannot, can I? I can make it better like this. There you go. This is as good as it gets. I just call a main function and inside that I run all of this logic. Harkirat, why? Why can't you do this? I cannot do this because you cannot have an await at the top level. And hence, I just copied all of this logic, put it in a main function, and then called the main function over here. I create a client, a Redis connection, I connect to it, and then I infinitely run a loop. Okay, bhai, is there any response? And as soon as I get a response, I just log it for now. Eventually, I should actually execute it. I wait for 1 second. If you don't understand this, but remove this line. It doesn't matter. Eventually, you'll have some, Docker orchestration here. And then you log something on screen. So that is the worker code. It's actually pretty straightforward. Chat went away somewhere. Okay. Let me open chat one more time, guys. Oh, there were a few Notion docs also. I will look at them very soon. But any more questions? Okay, a lot of questions. But if you integrate Redis with Docker volume, then will the data be lost if something went down? No. If you integrate with Redis volumes, as long as you're As long as you're mounting the place where, the append only log is stored, you'll be fine. You can most probably, like 99%, you can persist data if you have the volume mount to the right place. What do I mean by the right place? The place that has the snapshots stored. As long as you have volume mounted there, you'll be fine. How BRPOP makes sure that only one worker will pop the task? Do you remember when I said Redis is single threaded? What does that mean? That means wherever Redis is running, if this is my Mac machine where I'm running Redis currently on, inside Docker, this is running on a single core. So if two people do a BRPOP, bhai, I also want to do, Redis can only process one at a time. It is not running on multiple cores. It will first try to process this, and if it returns this guy something, second I will not get it. It cannot parallelly handle both of these requests. It runs on a single thread, which is why. Oh, am I sharing my screen? I am not. I was saying, if this is my Mac machine and I'm running Redis over here, and there are two people who have done BRPOP, then both of these people, Redis cannot process both of these requests together. It's probably catering to this and then catering to this and then catering to this, flipping between them. And then when it gets some item, if something gets pushed, it'll just send it to one of them. It cannot parallelly handle both the requests. It is running on a single thread. Run sequence. Harkirat, Redis runs on a single thread, it'll be slow. No. Thankfully, even though Redis runs on a single thread, it is incredibly fast. As fast as it can get. So, that's never a problem. My chat went away. I have to stop sharing it. Okay. Chat app project looks pretty good. What will happen after we pop our worker goes down? Yeah, that's a problem. That's a good question. So there you do acknowledgements a lot of time. That is a very good question. The question is, I missed this. Okay, Harkirat, what if you pop and then this goes down? You were not able to process. You popped it from the queue became empty, and then you weren't able to, actually solve the problem or, actually process the user submission because the Node.js process went down. You can add an acknowledgement to a queue. I'm pretty sure that Redis lets you do. Redis queue ack. Pub sub ack nack. There is a way to do this. I think there is a way like in Redis to do this by default. If not, you can implement it yourself as well. But okay, here's how you can implement it from first principles. Even though I think there is a way to do it in Redis, I'm happy to Google after the class and let you know. This is your queue, right? What can you do? I mean, I have a few ideas in my head, but all of them will have one case where it will break. Basically, if this question was asked to me in a system design interview, I would have failed. This is your queue. And in this queue, the one thing is, you can have whatever queue you have. If there is a Node.js process that is picking from that queue, it can be like, bro, I will take something. I will take something from this queue. But if I don't respond back in the next 5 seconds, I repeat, if I don't tell you back in the next 5 seconds, I am done, your process is done, then please push this again to the queue. I repeat, if you can have some sort of acknowledgement on every item, whoever is picking it, it's their responsibility to acknowledge back in 5 seconds either the submission was done, or if they don't acknowledge back, then the queue can assume it failed and add it back to the queue, or mark this as not processed so that someone else can pick it. Question is, how can you do it? I thought you can easily do it. Some argument BRPOP will accept. Like while you're popping, in the end you'll do a BR ack. Not exactly this, but I have a faint memory that you can do this in Redis. Does someone already know this? I'm sure someone in chat already knows this. No one knows this. Cool. No one knows this. I'll answer this question. I will forget this question, but I will still, but about that. What was it? How to do acts in queues in Redis. All right. Cool. That's a good question, dude. Let me look at the Notion docs. Not loading. Why WebSockets can be in both asynchronous and synchronous? Depends on your definition of asynchronous and synchronous. If your definition of asynchronous is here, I will send and the other person might pick the thing in their own time, then it is not asynchronous. When you send data via WebSockets, you send it immediately. कि भाई रख ले. So that is what makes it synchronous. But what makes it asynchronous? If you say that the definition of asynchronous is that whenever I am sending data, I don't worry about an acknowledgement. Whenever I'm sending data over WebSockets, I don't worry that bhai, the other side will send me something back. Then it is asynchronous. So the question really gets down to, what is the definition of asynchronous? And the answer is WebSockets, at least I think if you read online everywhere, it will tell you it's asynchronous because you don't worry about the response. Send it to the other side takes care of it. But I personally, was arguing it's probably synchronous. But I think if someone asks you in an interview, you say asynchronous. Suppose we clear Redis and then update Postgres. What if backend sends the request to Redis and Redis gets refreshed before the put operation in Postgres? Suppose we clear Redis and then update Postgres. Okay. What if backend sends request to Redis and Redis gets refreshed before put operation in refreshed? What does refreshed mean? Do you mean it gets cleared? Because if it gets cleared, you are fine. Redis is cleared. Redis has no data. And you're saying if the backend request came to update something and you sent a request to Redis, but in this process before the update happened here, Redis refreshed. What does refreshing mean? If refreshing means the data got cleared here, then you're fine because whenever the next get request comes, it will not find it in Redis and it will find the latest data from Postgres. If you mean when you say refreshed, it went down, then the answer for you is I told you whenever you're hitting the backend, you will first try to clear Redis. If this fails, you will tell the end user your request has failed. You cannot add a track. Only when the first clear happens, then update happens, then you tell the user that you are good to go. If only clear happens, it's fine. Clear Redis got cleared. In the next get request, it will get filled. The problem happens when you put data in Redis and put data here. When you put data in both the places, is when if one of them fails, you'll have a problem. Hopefully that's clear. How does Express.js backend server is pushing to Redis queue? We haven't provided any URL. Oh yeah, good question. Yeah, you can provide. Yeah, that's a good question. You can provide, Redis URL somewhere here. Create client. There you go. Something like this. In our case, it just picks the default URL and connects to localhost. But if you ever get a cloud Redis URL, if you go to console.avian.io, you can buy a free or get a free Redis create service. Create Redis. There you go. Get one for free. Then you'll have that URL. For example, I have this URL. Let me copy it. Then I can just, paste it. There's a way to just pass that argument here and then you're good to go. It might not be this, might be, something like more complex. Yeah. Username, whatever my username over here is. Let me reveal it, default. And you get the idea. You can, pass all of these here. And then, that is how your client will connect to this cloud Redis instance. Good question. What if we run Mongo container 1 and bind it to the same volume for project 1 and run Mongo container 2 with the same volume config for project 3? What if I start one Mongo container, bind it to the same volume path for project 1? Okay. and run Mongo container 2 with the same volume config for project 3. Do you mean what if I start two Mongo containers mount the data directly there to the same volume? And the question is that the answer is they will just remain in sync. If the first container when you put data, it will appear in the second container, so on and so forth. Before start teaching, just cross check layout. It always gets fixed when you reshared. Makes sense? Please do share Web3 cohort after 120. I want to join but can't cope up both simultaneously. We will see. I'm unsure when that will happen, but yeah, we'll see. All right, cool. I refresh the page, don't see any changes. Oh no, I see more changes. Oh, some. I use Postman request submission. Why can't see it in Redis CLI? It just me. You are doing a problems here. You're popping problems. Are you sure you're pushing to problems as well? When you do a L push, are you pushing to problems? Or are you pushing to submissions? That might be the only thing. Other than that, if you still see a problem, log this response. See what the response is. Debug from there. All right, that's done. This one I'm not able to start. I've started this. Oh, there you go. We use queues to have processes in queue. Whenever the worker is free, it will pick up the task from the queue. Correct. Redis is for caching data to make systems optimal. Does not make it useful. So it does not make not so useful requests. It does not make duplicate requests. It does not make, if this is your Postgres, so it doesn't overwhelm your database with reads. If you want to, cache some of these reads in Redis, it's not useless information. It's just, protecting your database with, a lot of reads. And Redis has also queues thingy, which will save multiple incoming requests and process them accordingly. It also has the queues. Can you elaborate on this? Whenever client on website makes a GET request, primary backend will make a request to the database and send it to the user, push that data in Redis in database. So whenever I make the same request and DB did not change, it will go from Redis. Whenever the client on website makes a GET request, primary backend will make a request to the database, correct, and send it to the user and also push it to the data to Redis, correct. So when I make the same request and DB did not change, it will get from Redis, yes. But you usually add an expiry. You make sure that this data is cached for 10 minutes. Or you write your code really well so that whenever there is an update happening, you clear Redis as well. But ideally, you just add expiries. It's fine if one request goes to the table every 20 minutes or 30 minutes. So there is some expiry here. Isn't AWS SQS same as Redis? SQS, simple queuing surface, is the same as a Redis queue. Redis provides you a database. Redis provides you a pub sub. More things it provides you. SQS is simply a queue. SNS is similar to messaging queue, I guess. No. So SNS, even though I've not used it, my guess is it's more similar to a pub sub. It is a notification system. SQS, simple queuing system. SNS, I have not used it, but 90%, 99% sure it's this. Simple notification system. This is used for maintaining a queue. This is used for there will be a notification system. I will notify on a topic, even though again I haven't used this, so don't quote me on this. Do Google this. Okay, this does the same thing, but my guess is it does. I will put something on a topic and then other processes can consume from a topic. So SNS is probably more similar to a pub sub. SQS is more similar to a queue. Both of these we've discussed in Redis right now. All right.